with larger memory. So you can see, I think this is very crucial for using TE in more in more scenarios, just like running the AI model or running the ZK circuit inside TE. Yeah, and what we introduced here is a TE SDK called DStack. So it's a FlashBots X project, which is jointly produced by Fala and FlashBots. So it has four major features here. So first is that the support for Docker images. So just make your own Docker Compose file. We will get this running on the TE directly. And second, it's equipped with the remote attestation APIs and the chain of trust virtualization on web UI. So any users, they can easily verify whether the application is really running inside the TE. The third, it's equipped with the automatic HTTPS, which means every application deployed in the TE will be equipped with a domain, and also with all the TLS certificate that is totally generated and managed in the TE. So the end user, they didn't even, they can just use the current TLS-based solutions to connect to your application. So the final thing is unique from the Fala part is that we will replace the current hardware-based root of trust with the decentralized root of trust that is controlled by the smart contract. So this means your application data is safe even if a single TE node is down, because the data is stored in something else. So you can just initiate a new TE instance to resume the execution. Yeah, so this is one interesting bot which is running powered by DStack. It's built by the Professor Andrew Miller from the FlashBot team, and he used a DStack to build it. So I would say it's different from the others like AI agents in that the whole stack is controlled by the machine. Just imagine, so from the X account, so the email account that control the X account, and also all the AI agents, the AI API key it's used, all of them are running inside the TE. So now we can see, okay, with this is a real AI agent that's controlled by the machine and you can trust. Yeah, and this will unlock a lot of interesting use case. Finally, we just published the world's first benchmark on the TE GPUs. So to show how usable, whether it's usable or not. So the overall conclusion here is that the average overhead is less than 9%, so which is quite good from my side. Yeah. And in the next, my colleagues, Josh, will show you the usage of DStack. Thank you.
Okay, so what I'm going to do is show you just the application that's deployed on our lab server right now, just to give you an idea. So here is a Next.js application. It's, that I've accessed publicly. You can go to this link if you would like as well. What I can do is derive a ECDSA key pair here. So this is an account that is within the TE. From there, I can start signing messages. And we can see TX signature here that you can verify. You can sign type data. So I actually used the VM SDK, just some of the examples they had in there, and just kind of made a mock template here that you can clone and then get started really quick. And then also I sent some funds to this wallet so that I can actually execute a transaction, and this sent 420 GUI to an account that I had just sent to the TE account that was derived. And then also another key feature as well is that you can also remotely do a remote attestation. So on this case, I actually created a remote attestation with some random data, and from there I'll just click here, and it should generate a quote. So I have my quote here. You can then copy this, go into the remote attestation explorer, paste it, verify, and here you can see that this is actually running in a TE environment with the TE simulator, which is what we have you be able to develop on locally. You would get something that would say unverified. But we can also do a little more checks, because you don't want to just trust like our block explorer and just take our word. So you can go on chain as well, and say you want to verify against Automata's verifier here, and you can see that we're verifying on chain, and you can also choose of the different networks that they support as well. So the next part I'll show you as well is another application that's deployed. Is just like a Jupyter notebook, so that you can see like you're able to also support whatever language you would like to build in, and you can then start to get a little more creative. But since you're able to connect to the socket for which is the TAPT socket here, you can then now have access to these two functions, which will be TDX quote, and the parameters that you would pass in is report data.
This Jupyter notebook itself is running inside TE.
So I'll zoom in here, so people can see here. But yeah, so you can run this here and get a quote. So I have a quote here, and then another key feature is derived keys. So you have this derived key function as well, where you would define your path. So you could define your like a root of trust, and then pass in a salt here from the subject. And whenever you generate this, you should this would generate the same key, I believe, on this one here, so that you can derive a key, and then you can then take this key and then either generate like a ECDSA key, or say ED25519, or whichever curve you would like to choose. But yeah, this is kind of like the power that you have with you by building, like Dockerizing your applications, and then being able to then run it in a TE. Some other things that you could get started with, I have created a little cheat sheet here that you can access at bit.ly/dstacks-cheat sheet. But anyways, here it'll tell you how to get started with the local simulator. You'll clone the repo and have the same Next.js application as well. I can zoom in here for anybody as well. And it'll show you how to get started in just a few steps, and then you're right away having an application running and being able to generate local remote attestations and deriving key pairs from there as well. One of the interesting things that we just have like packaged up, but want to see if any developer wants to kind of build upon it, is we created a repo called AI16Z TEE, and here you have a Docker file, and you can build your own AI agent that can run autonomously and be able to post on Twitter, answer on Discord with like voice or text. You can choose whichever LLM models through the Red Pill API, and also you can have it connect to Telegram, and then also use the derived key to generate wallet accounts for you, so that you can then start transacting on-chain autonomously with these agents. So you can really get creative, and we have a repo here in the cheat sheet for you to check out and get hacking on it however you would like. But I wanted to save some time instead of going deep into the demo to see if there's any questions that some of the audience may have. Oh yes. So if you go to the Fala network, so the question was, is there any templates or code that they can reference so that they can get started and be able to understand how to build, say, like a model within a TE? So if you go into the Follow Network repo here, we have a few templates under the TE sim template. So this is like the TE simulator. We have like a Python template, Red Pill template, a Next.js application. But if you have like any like kind of like example like where you want to run a model, please come by our booth. We're over here on this back wall so that we can kind of like guide you and tell you how you can get started really quick with this as well. Because we have our full engineering team for you to ask questions for us. Okay, so that'll be it for this talk today. But yeah, thank you for coming and have a great day.
Sure. Should we test the microphone? Can we test the microphone whether if I'm speaking like this, do I need to speak even closer? What? Try like put it, is there like a stand? No stand, right? So what's this for if you can't, right? So funny. You show your thing. This is so hard to, how can one give a workshop with one hand? Anyways, if I would speak here, like it's not loud enough, right? Do I stand here? No, right? Do I stand on the podium? I don't know what the video is. Oh, okay. So I will hold one hand and move with the other hand. Okay, okay, okay. I mean, if there's not a choice. Like that? Let me know when it's started. Do I need to turn on the mic? Testing? Like this? Okay. Oh. Did I share the screen? Oh, okay, okay, okay. Screen, yeah. We'll start now. Start now, yeah? Testing, testing. GM, everyone. My name is Elton, Developer Relations Lead for APAC at Circle. And today, I'll be going through Circle, more specifically the Circle platform, how you can actually get started building with the Circle platform. So I'll go through quickly what USDC is all about. USDC is the world's largest regulated digital dollar. And what it does, it gives you that dollar access without a bank account, it allows you to do cross-border payments at low cost and near instant settlements, also access to capital markets through trading and financial services. We solve problems like dollar access where, the currency devalue in LATAM, MENA, APAC. People resort to informal market exchanges, storing money in mattresses, which is not sustainable. That's why USDC come into handy by offering you that secure storage of digital dollar. Cross-border payments as well. Currently the solution to it is Swift. Swift takes a bit too long, takes a delay, takes a cut. Everything is not favorable. That's why USDC comes into the picture. It gives you that 24/7 settlement at a low cost. I'll be going through quickly about all this because I really want to go deeper into the technical. Some highlights. This is Rosen. It tries to solve the problem of cross-border payments and uses not just USDC, but as well as Circle's platform, more specifically the programmable wallets that allows you to embed the wallet into the application. In this case, in Rosen's application, to provide them a very seamless user experience interacting with their games and social features. NomNomPay is another example in the previous hackathon in ETHGlobal Singapore. They built an AI-powered social app on Telegram that utilizes almost all of Circle's platform products, from programmable wallet smart contract platform, CCTP that allows you to move USDC across chains, and also a research transact-to-transaction LLM protocol that allows you to power that AI application that you want to build. So what exactly is a Circle platform? Well, we are an open full-stack platform for you to build enterprise-grade chains, apps on-chain. We have the programmable wallets, which I will dive deeper into now, which is highly dynamic, highly scalable, highly secure. And the reason why I say scalable is because we have features that's really cool that if you guys want to try out, we have this thing called the compliance engine alongside the gas station, features of which are built on top of programmable wallets. So to give a little bit more context what programmable wallets is about, it's an embedded wallet you can embed into your application. And it has flexible key ownership because everyone has different use cases. If you want to have a user-controlled wallet or developer-controlled wallet, you can. So as the name suggests, the ownership lies with the user and the developer respectively. And you can do it all through a very familiar API and SDK, right? You can import SDK, you can call API, and you can build wallets. So you don't even need to learn Solidity, and you're able to build those wallets. We support both EVM and non-EVM as well. So it's a blockchain agnostic API. We utilize MPC technology, so it's highly secure. And we have this thing called a gas station, allows you to abstract gas fees, to provide your users a very seamless user experience. Last but not least, we have the UI console that allows you to track all the usage metrics, transactions, and allow you to troubleshoot all the problems that may arise from the dashboard. One very cool feature, if you guys really want to push the boundaries of blockchain, is modular wallets. We co-authored this with Alchemy, Ethereum Foundation, and QuantStem. This modular wallets allows you to build innovative use cases by plug and play different modules. For example, if you want to build a multi-sig wallet, you can. Something similar to Gnosis Safe. And if you want to do something like a biometrics passkey and session key to then generate a wallet, you can also do that. So that is very interesting if you want to build, like, for example, AI use case with like biometrics passkey to give them access, the AI agents, to then perform those automatic transactions. So modular wallet would be pretty interesting for you guys who are interested to build innovative use cases. It's not officially live yet, but you are able to view everything in the website erc-6900.io if I'm not wrong. So compliance engine, the feature that is built on top of programmable wallets, which I shared, is pretty interesting. It's for users, businesses who want to build compliance-related use cases. If you really want to stay compliant with your various jurisdictions, you can do so. We have many interesting features in the pipeline, one of which is transaction screening. Allows you to automate real-time checks to those very risky entities and transactions and perform those automatic transactions, automatic actions to be taken against those entities or transactions. For example, you can set different risk score categories, risk type, and it falls into that category. You can either freeze it, you can generate a wallet, you can also utilize, Circus sanction lists, and many cool features that allows you to stay compliant in your various jurisdictions. Gas station, as the name suggests, gives you that gas sponsorship for your end users, so they can start their journey in the application that you're building without having any cryptocurrency, right? That's more often the case where users find a problem whenever they start a crypto journey. So with Gas Station allows you to overcome that barrier for your users by sponsoring network fees on their behalf. Again, it's very easy for developers because we have that API for you, and you also can customize those policies through the UI console without any coding. So this is roughly how it looks like. If you really want to sponsor a set amount so you don't go overboard in sponsorship, you can do so. For example, if you want to spend like $1,000 USD, you can, or maybe a limit to the transaction or how many transactions you want to perform per day. The second component of this Circle platform I really want to talk about is the smart contract platform, especially good for people who want to quickly deploy smart contracts. That's also part of our bounties. So this allows you to create, deploy, manage smart contracts on the UI console itself, also with the API. It's all very intuitive, blockchain agnostic as well. You can use it to interact with the smart contracts, build once and ship on many chains. We also have those smart contract templates that's really pre-audited, so you can make use of it without writing any Solidity. Last but not least, I want to go through CCTP. Don't get confused with CCIP. CCIP is chain links. The users actually circle CCTP, they move USDC. So if you notice around here, like for example, Wormhole as well, we have this protocol called CCTP, Cross-Chain Transfer Protocol, that is a very low-level primitive. So all these different wrappers, bridges, applications, wallets, actually uses CCTP to move USDC securely across chains. So yeah, problem quickly go through right now. The blockchains exist in silo, and how funds actually move from one chain to another is through the lock and mint method, which obviously introduce security risks such as honeypots, where the amount of funds get locked up in a smart contract and hackers want to exploit that, right? It's fragmentation because there's so many unofficial bridges out there, you don't know which one to trust. And it's inefficient because it's just a representation of an asset, USDC in this case. So we support 9 chains as of now, Sui included. from Arbitrum, Avalanche-based Ethereum, OP, Polygon, POS, Solana. So if you want to build an interoperable product that is within all of these chains, I encourage you to build with CCTP. Right now we do not provide an SDK we are working towards potentially, but if you guys are having difficulty, either come to us or our booth is near the entrance, or you can utilize any of our partners, Wormhole or Chainlink, for instance, to kind of utilize our technology, CCTP, to move USDC across chains. Native USDC, if you actually use our low-level primitive, when you move one USDC from one chain to another, Arbitrum to Avalanche, for instance, you can expect one USDC on the other end. So this is, that's one-to-one transfer. Native USDC basically means instead of the locking and unlocking, it is a minting and burning, where the USDC is minted directly onto the chain, and this version of the USDC is backed fully by the US reserves, and it undergoes very rigorous audits and checks. So you can rest assured that this native USDC that is on these 9 different blockchains are all very secure and compliant. Unified liquidity, because it exists not in just one blockchain silo and many, many different chains that we support as well. So to give a little bit understanding context of how CCTP, if you really want to use our native CCTP, is a set of composable smart contracts, and it's paired with Circus off-chain attestation service. And what it does is it provides an automated way to validate the authenticity of the transactions, very similar to how Circle Mint works. So like I mentioned before, most of the wrapper that you see here that assists you in creating a very nice developer experience, but of course we are working towards that as well. Apps, wallets, bridges, they all, when they want to move USDC securely, and they most likely will be using our protocol CCTP. So how it works is when the user initiates a transaction, right, with CCTP, the app then facilitates a burn event. So it's not really locking and unminting. It's not locking and unlocking, but rather a burning and respectively minting of the asset. So after it burns, Circle then monitors the event that has been emitted, and then you can just call the API SDK, right, and then retrieve that attestation so that you can use the attestation to then mint on the destination chain, and then respectively to the recipient wallet address. So this way, there's no honeypot, there's no security risk, no money locked up in smart contracts for hackers to exploit. You can rest assured that it's secure because it is it's a native USDC moving through CCTP. So in summary, programmable wallet, smart contract platform, CCTP are our tech stack. You guys can look through building this. Programmable wallets is embedded wallets, right? So if you want to build embedded wallets, I highly encourage you guys to do those, to use our tech stack, to deploy smart contracts and our smart contract platform, interoperable product CCTP. We also have our bounties also includes the USDC and EURC. So if you want to make interesting use cases with both stable coins, it'd be very interesting to see as a judge perspective as well. So this part is the price pool information. We are sponsoring $10,000, USDC and EURC 1,005. So of course, just implementing USDC and EURC would you be eligible for the price? But of course, we want to see innovative use case that uses both USDC and EURC, because we only have one bounty. The second, the programmable wallets and smart contract platform notice, and we encourage you to use both the tech stack, both programmable wallets and smart contract platform. If you use them, right, the more tech stack you use, the higher chance you stand in winning our respective prizes. We have 2.5K, 2K, and 1.5K to be given out. And yeah, none that I've already gone through. You can also leverage on the compliance engine, the transaction monitoring, and to kind of play around as a feature on top of programmable wallets. Last but not least, CCTP. You can also use any of our partners like TechStack, but if you really want to challenge yourself and build directly with our low-level primitive CCTP, we also encourage that. Any questions? Our booth, again, is near the entrance for you guys to find us. And we have a very special bounty. You guys stay to the end, so you guys get a special prize. $500 on top of our existing bounties, just by submitting feedback. Extensive as you can, journal document, you can write in a way that we imagine you see as taking the feedback and actually implementing that suggested change. If it's extensive, we only award 5 entries, $100 each. So we encourage you guys to give feedback. So the best way to learn, is by a quote by Walt Disney, the only way to get started is quit talking and begin doing. So don't just take my presentation, really try to use our tech stack and build something cool in this hackathon. And our Twitter and Discord is here. Twitter's on the left, Discord's on the right. Any technical questions, we are 24/7. We have a global team, DevRel team that's on standby to support you with every question. If not, we are physically present as well at the booth there. My Twitter's handle is that, if you guys want to follow. And our Twitter is that. So that's not really the end of my presentation. Let me check how much time I have left. 5 minutes. Just want to share a little bit more things. This is Chainlink stuff example. But I really want to go through something cool that we released not too long ago called AI Agents. It's pretty hot recently. And you guys can check out our blog, right? Enabling AI agents with blockchain. I'm going to make it a little bit bigger. And we have a DevRel of ours, my same team, Blessing, that created a document, a very extensive document, as well as a GitHub repository that you guys can read up about if you really want to learn about how can you couple AI agents with Circus tech stack in building. For example, in this case, what Blessing did was use Circus programmable wallet, USDC, and they use it with AI agent. So they gave each of the AI agent a wallet. We gave them USDC, and if each task has been completed, it awards. So how this works is, in this example, again, I would not go through because I lack the time for you guys to go through. He is just one of many examples because it's AI agents. They gave like 5 different roles: engineer, scientist, planner, executor, critic, and each of them have their obviously specific role to perform. And once they do perform that role, they get awarded USDC. This is just an example of how you can automate payments for the AI agents, without any manual intervention. So have a read. I highly encourage you guys, if you want to build AI and blockchain applications, to have a read at this. It will show you stuff like even how you can spin up the wallets for the users, for AI agents. So again, most of these codes are also replicated from our documentations. If you think our documentations need some improvement, again, the feedback bounty is there for you guys to give feedback for. And you get $100 if you provide a very good feedback. And I think there's one other partner that really want to go through something called VLayer. So, example, I think VLayer does something interesting like time travel, transport. So these are other ways that you can think of, not just using Circle Tech Stack, but as you walk around this hall that has so many sponsors, to think about what other interesting use cases you guys can build as well. But yeah, I think, what else would I want to say? Nothing. I'm not sure I can open the floor for Q&A now. I think I have 3 minutes. If not, you can also ask me questions after this Q&A session. Anyone here has any questions? For the bridge, so your question is whether bridge only move USDC. Right now, the cross-chain transfer protocol moves only USDC. So if you really want to move any other tokens at this point of time, you can do so with another protocol, for instance, wormhole to move the other tokens, and then Circus CCTP to move the USDC. So yeah. If there's no other questions, I'm going to end off here. Thank you all for your kind attention, and I'll be lingering around here for any questions. Thank you. Oh, nice. You guys came out.
Okay. So, hi everybody. I'm Harry. I work at Oasis, and before we start, I'd like a show of hands in the wonderful crowded audience we have. But yeah, so today I'm going to be covering the Oasis protocol. What kind of projects can you build with it? So first, there's an EVM compatible chain with a confidential state and contract. So that's Oasis Sapphire. And then we also have a Ruffle, which is the off-chain runtime compute with verifiable compute and internet access. And again, it also has confidential state. So we have a EVM ecosystem and an off-chain ecosystem where you can run lots of compute, pull data, post it on-chain, that kind of thing. So the QR code here goes to the cheat sheet, please. We have physical cheat sheets as well, and you can come visit our booth. So for Sapphire, the easiest way to get started is to go to the Explorer and request some tokens. So we've been in production for the past 2 years, but the testnet is free to deploy in and test on. On the testnet Explorer, there's a request test tokens button, and you'll see the tokens appear in MetaMask or whichever Ethereum compatible wallet you're using. And we have a handful of different prizes here. If you're thinking about what to build, we have several different tiers. For Sapphire, you do have to deploy contracts on-chain. But for Ruffle, while you can communicate with Sapphire and it has an authenticated, verified link to post transactions, you don't necessarily have to deploy everything on Sapphire. You can run off-chain logic, but it is powered by our infrastructure. Also, to help you get started, we have a playground. So that's lots and lots of ideas and projects from hackathons in the past, where if you're thinking about need some boilerplates or want to fork something and see how they solved a problem, this is a really, really good place to start because there's lots of resources available. So I think I'll very quickly cover Sapphire. So it's a confidential EVM that enables a private smart contract execution. It's Ethereum compatible, but the contracts have encrypted storage. So the runtime state is encrypted, which means the node operators can't see what's going on. So if you mark a variable as private or internal in Solidity, only the contract will be able to access it, as users can only run public methods and access public variables. It also has a call data encryption. So you have an end-to-end encrypted channel between the dApp that's in the user's browser and the smart contract. So this gives you MEV protection for free because no one can see the contents of the transaction. Of course, we have 6-second block times. And because we're using a delegated proof-of-stake architecture, so we are an L1, you get a finality as soon as the block is mined, which can be really useful. So behind the scenes, we're using Intel SGX, which is the hardware-based security for privacy and confidentiality. So there's no proving time, and there's no complicated MPC. And importantly, because it's in a trusted execution environment, you have instant on-chain randomness available inside Sapphire Solidity contracts. So on the cheat sheet, we have a few different examples, and one is the Sapphire-contracts package on NPM, which gives you Solidity libraries to generate precompiles, but also generate key pairs, verify signatures, sign transactions, do encryption, and doing decryption. If you have any questions about more specifically, I can get into this afterwards. So the testnet, which you may want to deploy contracts on, here's a QR code for the faucet. We also have a testnet explorer, and here's the chain ID as well, so you can add that into your MetaMask. And I think to illustrate what we're doing with Sapphire is we have the sapphire.sol library that can be imported. So we have the sapphire.sol library which can be imported. So you can generate a random number by calling sapphire.randombytes. And they're all precompiled, so they're built in and they're very cheap to execute versus implementing this all in Solidity. One of the interesting things is if you can generate an Ethereum transaction and sign it on-chain using a key pair that's managed by a contract, then you can get gasless transactions. So the contract can sponsor your gas for you. Instead of needing the external infrastructure like ERC4 773, or is it 47? Yeah. And so those of you who might have followed the account abstraction debates, we're working to make it much more simple and straightforward. And for us, it already works on production. We're using gasless sponsored transfers. I'm also thinking of one of the main differences with confidential EVM is you have to authenticate your users. So on the Ethereum ecosystem, everything's public, everybody can see everything. But when you come to confidential EVM, you don't want people to be able to impersonate you. So how do we verify the user's authenticity, that they control a wallet? And this starts to look a lot like the Web 2 world, where you would log in, it gives you a cookie, and the cookie proves who you are, and you can then send this through to the contract. So in this example, we're using sign-in with Ethereum, which allows you to sign specifically for a domain name with MetaMask integration that will warn people if they're on the wrong site. So it has like anti-phishing built in. And this is really easy to integrate with your smart contracts, but it shows you have to think a little bit differently about how to solve some problems or take advantage of the confidential state and the confidential runtime. What we're working on now, though, is we thought it would be really cool to use these trust execution environments to do things that you can't do on-chain. So instead of being limited to Solidity smart contracts, what if I want to retrieve data from the internet? I want to pull information from oracles. I want to submit RPC requests or interact across different chains. And it's obviously much cheaper to perform the compute off-chain. And we can use the blockchain part, Sapphire, for runtime signaling, communication, some locking, token transfers, that kind of thing. So we combine the two worlds. You have the performance of the off-chain world and the trust of the on-chain world. And we're calling this ROFL, so it's a runtime off-chain logic. And on our roadmap at the moment, we're looking at, well, this is perfect for AI. We want machine learning that's confidential, so you can prove that your model was trained on a specific set, or you can verify that inference is running deterministically. But it's not just high compute workloads. You can operate across lots of different chains by accessing the RPCs directly. You can manage keys inside. You can ask the contracts to manage keys for you. And there's a lot that you can do. So for gaming, a lot of chains are trying to increase the block speed. And we're saying we should actually move this logic. If you want real-time logic, let's move this off-chain so that you can have 30 millisecond, 60 millisecond responses. So anyone familiar with Oracle, with DEXs, you do need an Oracle behind the scenes to be able to fetch information from other chains, such as price quotes. And now you can run this inside ROFL. And you can trust it because it runs inside the trusted enclave. So you get verifiability, and to a certain extent, you also get privacy and censorship resistance. And that's all because it's running inside the trusted enclave. So each Oasis node can run ROFL apps inside the trusted execution environment, and they all have a light client, and they're verifying the attestations of the network and of the consensus level. So the ROFL app will communicate with Sapphire. So any storage, such as storing the private key, the ROFL apps don't have storage of themselves. So you would want to store that and manage it in a smart contract. And you can also open a HTTPS connection, which is something you can't do inside a smart contract. And that means you can connect to Amazon or eBay indirectly via Solidity. Or you can prove that you connected to Amazon and prove that to Solidity. But that's because the off-chain logic is non-deterministic, whereas the on-chain logic is deterministic. So with here, you've got the example where we're opening a HTTPS connection. We can do whatever programming we want. We can process the data, use JSON, CBOR, XML, extract whatever you want, summarize it, and then maybe you can store it again on-chain, just the summary, or you can fetch some extra information from on-chain in order to process it. So we made a small example of this. This is how you build an oracle using Ruffle. That will fetch the price information from Binance, and every block it will submit a transaction which stores this data on-chain. So this is the Solidity part. You know, say if you want to authenticate the Ruffle component, each Ruffle app has its own app ID, like it's in the App Store. So that means you can put the app ID of the off-chain component into the smart contract, but you can also update the off-chain component, so you can publish updated versions, which means you don't have to worry about upgrading the smart contracts to point to the new off-chain component. So what we do here is we've got it built in as well to verify the identity of the off-chain component, and then enforce authentication so that only the off-chain component can submit new information. And of course, the submit observation submission is in the main function. But it basically just pushes the observations and price quotes, which yeah, you could also include things like a timestamp if you wanted. It's all written in Rust, unfortunately, so if you want to build off-chain components, this is the Rust side of things, which fetches the price quotes. Because you know, Ethereum doesn't know anything about the floating point operation, we're multiplying it by 1,000,000 to convert it to an integer. So you have to be wary of encoding it for Solidity for the Ethereum environment. And we saw this price by submitting a transaction to invoke the submit observation method in the smart contract. We also set the gas fee and then sign and submit transaction, which is using the built-in signer with Ruffle. So that's the account that's running the Ruffle that ends up paying for the gas. Although you can submit transactions and pay gas from other accounts if you want. And behind the scenes, we've got a light client that's broadcasting it to the network. And here's the boilerplate. So if you're going to deploy your Ruffle app, you will want to anchor it to some chain, verify that it's started, and then we have the hook here, which is on every single block. We run the oracle and error out if that fails. So if you're running Ruffle and you want to test your components, we have the full stack running inside a Docker image. We have the local net, which is the same as testnet and mainnet, where if you want to use precompiles to do any of the cryptography stuff or randomness, you can test this locally, and it has an instant mine. Or you can use the testnet, which has 6-second block time, so unit tests will run quicker locally if you want to do that. But it does mean that if you just start up Hardhat, you won't be able to use the VRF, for example. So here we have the RPC gateway on 8545, and we have the local net explorer on 8548. And yeah, it works the same as testnet and mainnet. So for local net, you can add this into your MetaMask. So again, localhost 8545. We have the chain ID there, and you can change the mnemonic or use any mnemonic you want, and you will be provided with local net tokens if you use the standard test junk mnemonic. Oops. So secondly, for the hackathon here, I'd like to point out some resources. You have the docs.oasis.io, which is like the holy Bible for everything. We have the dApp/Sapphire subpage for everything related to Sapphire and building dApps. There's the Ruffle subpage for everything related to Ruffle, so how to build a full tutorial. And if you're building a cross-chain app, we have information about bridges on the dApp/OPL page. So OPL is the Oasis privacy layer, where we have 2 different bridges. One is router protocol, and one is seller IM. And finally, here's the cheat sheet. So we do have physical paper copies of those at the booth, or you can see the blue sheets of paper, and you can scan the QR code. So it's, you know what a cheat sheet is, it's A4 crammed with QR codes and useful information. So you've got the wallet, the Explorer, the faucet, and you know how to run the Docker container, some code examples, all the package names. It's really, really useful, and you've got a cheat sheet there. So I think at this point, if anybody has any open questions, then feel free to ask. If not, we can talk afterwards. I can bounce some ideas around, that kind of thing. So thanks, everybody. Yeah. Hello, sir.
So I'm not sure if I understood the connection between Raffle and the Sapphire mainnet. Like is it the idea that the contract on mainnet will verify that only the contract on the T can call it? Like there's a 6-second block time, you know, in the T in a Raffle it's running instantly. So how does that work?
Okay, so in terms of like how does the Sapphire mainnet verify the Raffle components? So we have a verification of attestation built into the Oasis ecosystem. So that means that instead of having to verify the Raffle component on every call, we have that behind the scenes, and then we have like a different type of address that shows that this has come from a specific Raffle app ID. Then that means that as long as you put the app ID into the contract, then when you're publishing your Raffle application, you can keep the same app ID, but update the version. So that means that you can have a lot faster developments with very stable contracts on Solid Sapphire mainnet. Does that ask a?
It's like with the Binance Oracle example, what would the flow be? Would someone be calling the contract on Raffle and then that's being automatically posted to Sapphire every 6 seconds, or like, yeah?
So in the example, every block is posting a transaction, is fetching the information, posting a transaction to Sapphire. But that's just one of the examples. The second thing is, well, you can run long-running tasks in the Raffle. So you don't have to submit transactions whenever. You can run cron jobs, you can do multiple threads, have some processing in one thread, have a cron job in another thread. It can query the chain, so you can have a contract that will notify the off-chain component that there's work to do. Or you could have the off-chain component connect via socket IO to some kind of pub sub, and you can distribute work to it there. The main thing is the main thing is that there is the authenticated link, and you can access the Ethereum ecosystem with gas payments and stuff either via signing your own transactions or going through Sapphire and using the ecosystem there. Fantastic.
So do we need an Intel-based system to run Raffle, or Raffle needs SGX, right? So do we need an Intel-based system to run Raffle, or can you run on Mac?
So the question is, do we need Intel SGX to be able to run Sapphire or to be able to run Raffles? So if you're developing them, you want to run them locally, but if you want to deploy them, you will need SGX. So so if you're developing for the hackathon, then as long as it works, you can run it end to end locally. You restart the Docker image, and it will automatically load up your Raffles. And there's a command to build it. And then you've got the local net Explorer where you can see your transactions coming in. Unfortunately, because it's confidential, you can't debug it on chain. Yeah.
So just move it there and you'll see.
Can I just share my whole screen right like this so that
I'm not sure how.
we ask?
Yeah,
I'm ready.
Yeah, one
So,
second.
hey, test, test. How are y'all doing? Oh, I see. Okay, there's my pink wallpaper. Let's try to drag it over. There we go. So I can't see what I'm clicking on, is the problem. Is there any way that I can share? I'd like to be able to. Cool. All right. We're going to get rolling here. Sound good? All good? Everybody hear me okay? Coming through all right on the stream or for later? Awesome. So great. Well, hey, this has been a wild week here in Bangkok, and what an exciting first day to ETHGlobal. I think it's going to be amazing to see what people come up with by the end of this weekend. So my name's Will. I work on base. We're building a global economy to increase innovation, freedom, and creativity in the world. We've been around about a year and a half. This last week we did our billionth transaction on chain, and we feel like we're just getting started. A little bit more about me. I've been in this space for about 11 years. I started in Bitcoin, amazing space, kind of my pill that opened my eyes to like, hey, we have this system that we can all be a part of that's better for everyone. And so super talented developers in that. And we also quickly realized that we need this to be faster. It can't be every 10 minutes we have these transactions confirming on average. So we got to build something better. And in that we saw the inception of Ethereum and how amazing it was for building smart contract applications and even more developer talent coming into the space. And then in that, we also saw, it's great, it's super fast, but damn it, it's too expensive now. So, but here we are today. We have all kinds of new L2s on top of Ethereum. And in the future, just like you all here, you all online, people are going to come on chain. They're not even going to realize what network they're on. It's going to be like me calling any one of you. I have no idea who your mobile operator is. It just works. And so, like, we're all in this together. There's always like competition and stuff, but like we solve these problems. We make crypto easy for everybody. We all win. Like this is the first days of like an open internet. We've been part of this space for years, but it really is still the very beginning. And so I think my challenge that I would put forth to the world, people here, is this is the beginning of like a new open internet. And it's not just Base, it's all of us. And so for us as builders, what would you build if thinking back to the beginning of the smartphone era when we saw the iPhone come out, and then all of a sudden just in the span of really 6 months to a year, we have hundreds, thousands of apps that now everybody around the whole world uses. And so that same thing is going to happen in the future with us. And we're the first builders. And so with that, it's a gift. but it's also a challenge. So what can we build? And so this workshop, super high level, it's just getting started building on base. A lot of this is just going to be applicable to getting started building on chain. And so I'm not going to go through just slide after slide after slide. I'm going to take a quick drive through just our website, just really trying to empower you and help you get started building on chain. And so first off, the most important thing about, if you're interested in Base, utilizing it, is bookmark base.org. And so this is base.org right here, and I'm going to skip straight over to the most important page after base.org that you should know, which is base.org/get started. This page is going to have everything that you need to not only learn more about what Base is, but to get started building on it. And so we're just going to take a click through this together. I'm going to just do a quick explainer on like what each one of these things are, and then at the end of this workshop, it'll just be an opportunity for you can come to I'm going to share a link. It's actually on the ETHGlobal page. We have a much smaller builder telegram where you can come ask questions throughout ETHGlobal this weekend. This awesome hackathon in front of us, but even more so, maybe it's next week, maybe it's 2 months from now. Like, we're here, the Base team, other folks throughout the Base community are here to support you all. So this is our getting started page. What do these things mean? So you see right here, like, create your profile. I don't know if any of you all came to the ENS talk earlier today. We have something called base names, and so it's actually built on top of ENS. Like, we're trying to abstract away this whole like complicated thing like what's your address. It's actually just be like what's your name? What's your base name is what we call it. And so again, in the future, like, we've all been through this kind of scenario of we want to bring people into the space, and it's super complicated for way too many people to have to remember like a long string of numbers and letters to be able to do something with them. So highly recommend you start thinking about that as you're building applications that you're building for the future, not where it's the person that's already been like in this space for a few years. It's actually like our friends, our family, like normies, people that have heard about crypto. They're starting to get more interested in it. This landscape's changing fast. Like, those types of people are only going to need to know, like, what's your ENS? What's your base name? So definitely go there, click there on create your profile, check out what base names are. I'm going to also just kind of do a quick scroll through like on the elements of this page and then get to the most important part, which is getting started building on Base. We also have opportunities here well beyond ETHGlobal. If you want to fund your project, we have an ecosystem fund for just early stage projects. We also have rounds grants, which is every single week on the Base Builds channel on Farcaster, people are getting ETH just for building on Base. And it's just building in public, joining that channel, posting what you made, people are getting ETH. So we're really trying to support folks who are trying to, maybe it starts out as a side hustle, maybe it's just, I want to mess around with my idea this weekend. Like, okay, hey, that was pretty cool. Like, we're really trying to incentivize that. And so check out the rounds grants, and I'm gonna save a little bit of time for questions at the end. So, but let me keep rolling. Also, gas credits. I think now you can get up to $15,000 worth of gas credits, which means, like, if you think of the Web 2 model, we all have seen this like freemium idea of like, hey, I'm going to try this out before I buy it. This has been broken for forever in crypto, where before anybody can do anything with your app, give me some money. And it makes it really, really, really hard to get new users. And so with gas credits, you can actually set it up so that the moment somebody comes to what you built, they can start using it immediately. They don't have to have any ETH. They can decide, like, is this cool? Is this something I want to use more? So check out the gas credits for that. I'm going to skip through, like, get noticed. Like, I'm going to come back to community at the end. But as far as starting building, the first thing here is our docs. If I click over here into, actually, I'm just going to pull it straight up, docs.base.org. We have this set up to where no matter where you fall across the developer spectrum, if you've already been building on chain for quite a while, you're probably just going to want to click straight into the docs section here, we have all kinds of tooling that should make it really easy for you to just hit the ground running this weekend, online, if you're building this weekend, next week. There's all kinds of tools that are already available. The things that work on L1, on ETH mainnet, it all works on Base. It's also going to work on other L2s, anything on the OP stack, anything that's EVM compatible, you can use these tools. And so just give it a quick scroll through, bookmark docs.base.org. Also, if you're super new in the space, you can also check out our Learn section. This is free. It's gonna it's gonna be intense, but it's kind of like the gym. You're not gonna see results today, later this week, but you get in here. This is also gonna get you up and running, teach you enough to be dangerous building on chain, so that you can start doing your own stuff, building your own apps, or working with other teams that are looking for people to help join up with them. And then one other section I wanted to highlight here. If you're somewhere in between, we also have a great tutorial section. It's got all kinds of just different examples of like things you can do to learn more about specific scenarios where it might not be clear like how to get things done. So give that a quick scroll through. Continuing on, probably one of the most important, actually the two most important things that I think you can take away from this workshop about building on chain is it's actually getting much, much, much easier to build on chain now. And one of the first things that I would highlight here is on-chain kit. And so what is on-chain kit? And so this this time I feel like in the world is probably one of the best times ever to be getting started or building more in this space. And it's because it's becoming way easier to do that. And so on-chain kit is completely open source. It's our effort to try to make it as simple as possible for you to get up and running. Also just adding features to apps that you're building. And so this is onchainkit.xyz, and it's super easy to install from the CLI. But what is it? Well, it's going to allow you to do things like setting it up so people can connect a wallet. This is already integrated with one thing I'm going to touch on in just a moment, which is Smart Wallet, which means that somebody can create a wallet without actually even leaving your website. You can also add swapping so that somebody can start trading straight from your site. You want to do e-commerce, you want to sell something. That's possible with on-chain kit directly from your site, doing transactions. It's also integrated with ENS, base names, straight from your site. And so all that can be done in minutes. You can build a whole app. We also have templates here. Might be hard to see on my screen, but where you can actually start with a full-blown app and then start deconstructing it. That's also something you might want to think about for this weekend. If you're not really sure what you want to do, take the template, start pulling it apart today and see like where your idea can start to form within that. And so the last thing here before I take questions is Smart Wallet. I'm just going to touch on it for a moment. Smart Wallet, if you've been in this space for a while, you've been trying to help folks get on chain, like connect your friends. Everybody's kind of gone through that weird conversation where, okay, you're going to need a wallet. You don't have one. Okay, you need to pick from these different wallets. Okay, go over to the App Store or the Play Store. Go to, you're going to need some ETH. You need to go back over to an exchange. And so some people that are really passionate are going to do that. And then other people are going to be like, this is too damn complicated. No, thank you. And the good news is you don't have to do that anymore. And so this is on Coinbase. Like Smart Wallet's completely open source. It's self-custodial. I wanted to just highlight a website, especially for us builders here, which is smartwallet.dev/y. And so this is going to give you everything you need to start bringing Smart Wallet in. When I was talking about on-chain kit just a moment ago, good news is it's already integrated. So you don't even have to come here. But it's also going to give you insight into like how do I do like gasless transactions and stuff like that. So lastly, before I take questions, I was just going to do a quick drive-through. Like, hey, we're here at ETHGlobal. Like, Base is sponsoring some prizes. So we're doing two main prizes. One's just like the most Base award. Like we're really just trying to. Like, a lot of us here have been in this space for a while, but it's more and more people are doing it, but the real growth is going to come from all these folks that have heard about crypto. They know about crypto, but they haven't used crypto. So how do we start thinking about like these Web 2 apps that everybody's using, social and whatnot, where it's literally a walled setting that nobody can get out of, that people are creating content in, that ultimately I feel like is starting to fail in favor of a new open internet that everybody can be part of, that everybody's incentivized to be a part of. And so for that, we have a Most Based Award. You can get this on the ETHGlobal website. And then I was just talking about on-chain kit. Like, really, there's no, like, I'm not just being biased here. Like, there's a component within on-chain kit I highly feel like could be useful to anybody here. So just like, I mean, check it out. Like, maybe it's swapping. Maybe you want to think about, hey, how can I use ENS more easily within my app? Like, check it out at on-chain kit. There's probably also going to be code there. It's open source. Pull it out, use it in your app. And then the last thing I just wanted to call out here before I take questions, there's a link here under resources for the Base Builder Telegram. It's a much smaller group. Our base Discord, it has like almost, I think, 425,000 people in it. There's like 20,000 people online at any given time. Go to the Base Builder Telegram because there's only like, you know, maybe about 100 devs, like people really focused on building stuff, and it's like very distilled conversation that can be helpful. And so if you have questions this weekend, join there, ask them in there. I'll be there. Other people from the team will be there. Other people in the community will be there to try to help support you. So, yeah, I know that was pretty fast, but thank you all for sharing time to be here, and just think it's so awesome seeing this energy. And questions? How's it going? Let me make sure I can. Okay, we've got a microphone.
Yeah, two questions. The first.
Two questions.
The Farcaster channel that you mentioned.
Yes.
What's the name?
Okay, so that's warpcast.com/base-builds. The question was, what's the Farcaster channel where each week, like as part of rounds, you can get ETH just for building on chain? That's warpcast.com/base-builds. And just also riffing on that for a moment, we're expanding it even further, where it's not even just, we don't even think of building as just writing code, but anyone can be a builder. Maybe it's creating community, maybe it's creating content. And so Base Build's mainly for like developers, but we're also splitting that into a Base Creators channel, and stay tuned, we're gonna be doing a Base Community channel. So if you're hearing about this for the first time, highly recommend going to Base Builds. We'll also announce it in that. These other ones where really we want to set up a contribution path where people are like, hey, I don't really like the part of the world that I'm in. I don't like these closed systems that I'm a part of. I want to break the fuck out. So let's try to help each other do that, and let's set up contribution paths. So we're really trying to set that up for everybody.
Yeah, and
part of my language.
and the Farcaster protocol, everyone should take a look at that. It's
What
a great
were you saying
community.
about the Farcaster?
Farcast, that everyone should take a look
Oh
at.
yeah, thanks for mentioning that. If you've never checked out Farcaster, it's kind of like a so it's built on the OP stack and OP mainnet in particular. It's kind of like a mashup between Reddit because it's got channels, and it's also got the feed that you see like on Twitter. And so a client for Farcaster that y'all can definitely check out is Warpcast, and so you can get that on warpcast.com. And it's probably one of the most positive, least toxic social networks that I've ever been a part of. And it's just I guess it's gonna sound cheesy, but I guarantee you there's a channel for you on there. Like it's everything on that network. So check out Farcaster.
And the second question was, Coin and Coinbase, is there a relationship there or not relationship?
So I think they're giving me time, but I want to make sure I answer that question. So Base started as a special project within Coinbase, but Base is actually decentralizing outside of Coinbase so that no matter what happens to Coinbase, Base continues to exist. As an example of that, we just came one step closer to stage 1 decentralization by introducing fault proofs. And what that means is Coinbase disappears from the planet right now. The Base core team disappears from the planet right now. It's still possible to deposit and withdraw from Base without any type of centralized oversight. And our goal is to continue to further decentralize so that no matter what, like the only way you can turn off Base, you have to turn off the internet. You have to unplug all the electricity. So on that note, thank you all again for being here, just sharing time, and hope you all have a great time at ETHGlobal. So take care. Cheers.
Good job. Thank you for it a lot. Man. Have you been to East London this year?
Yeah.
I was at the workshop as well. Then,
Awesome.
with you, yeah.
Yeah. Whoop. Yeah. Okay. One sec. I need to change my settings here to mirror.
Display settings. Yeah.
All right. Hi, everyone. I'm Ian. I do DevRel for World, and I'm here to tell you about building for real humans. So we have this one really big, important question here. How do you know who is a real and unique person online? You might think about CAPTCHAs or things like that, but it's really hard to solve this problem in a really powerful, strict way. But that's what we built World ID for. World ID is our proof of personhood protocol, letting your application know that this user is a real human with only one account, but with that user not revealing anything about which real human they are, right? So I'm a unique human. I'm doing an action only once, or really however many number of times you want, and optionally with this tamper-proof message that we call the signal. We've built World ID to be private, inclusive, and robust. We don't want the user to have to reveal extra information about who they are. We want as many real humans as possible to be able to use this technology, and we want to make sure that it's robust, ensuring that every real human only gets this one account. And when we think about how to meet all of those requirements, with email and phone numbers, they don't work super well. I have many emails, I have multiple phone numbers. We might think that KYC of official government IDs is the way to go, but less than half of the global population has a digitally verifiable government ID, so it's not scalable enough for us. Web of trust systems also don't scale to all of humanity in their current implementations very well. Most web of trust systems start with an initial trusted set of 100 or 1,000 people, but scaling that to 8 billion doesn't really work that well, because every hop away from that initial trusted set you are in a web of trust is really the less trusted you can actually be. And so we settled on using biometrics because they can be unique to every human. There is obviously the human component of biometrics at all, but there's multiple different biometric factors that we can use. We looked at fingerprints, palm scans, face scans, right? Things that you might be more familiar with for Touch ID or Face ID on your phones. But those actually don't have enough entropy to determine uniqueness at the scale of all of humanity, right? Face ID on my phone can distinguish about 1 in a few million people, which is totally fine for unlocking my phone. I like those odds a lot. But 1 in a million for determining if you're unique amongst all 8 billion or so humans that exist breaks down really, really quickly. We also took a quick look at DNA, right? It's very, very unique to every individual, but it can't be done in a private manner, right? There's no way that we could say we don't know anything about who you are if there's DNA involved. So ultimately, we settled on using the iris, which has a lot of entropy. It's unique to every human. Even identical twins have very different irises. And it's also something that requires a level of consent, right? You can close your eyes if you don't want someone to see your iris, It's not something that can be scanned like passively while you're walking past on the street. Like your face could be, you're not leaving fingerprints or like palm prints everywhere like you are on glasses at restaurants and things like that. So then how do we actually use these iris biometrics? Phone sensors just aren't high quality enough. There's one phone I'm aware of that did have an iris scanner for unlocking. It was very easily broken with like some hard contact lenses and printing an iris on a piece of paper. We looked at off-the-shelf hardware, like what Clear uses at airports in the United States for a faster line through security, but they're really big, they're expensive, they don't meet the requirements that we have. So we became a hardware project and had to build custom hardware, just because we care about solving this problem as effectively as we can. And that hardware is the orb. So the orb has a couple different sensors on it. Its job is to first make sure you're actually a human, running over a dozen machine learning models locally on the orb. It takes a photo of each iris and calculates this iris code, this digital representation of the pattern of your iris. And that's what we use to check and make sure that you're unique. These iris codes are stored in this really fascinating MPC system. If you want to learn more about like the cryptography behind that, how we do this super privately and super safely and securely, I'm happy to chat about that at our booth after this workshop. But once we know that iris code is unique, your World ID gets verified. And your World ID is essentially just a key pair in World app on your phone. Verifying it means that the public key goes into a Merkle tree on Ethereum mainnet. It's essentially just the list of verified World IDs. And we've built this whole system to be privacy first, decentralized, and open source, right? Everything about the protocol is open source. The majority of the Orb hardware and firmware and software is open source. I can go more into decentralization at the booth, like too many like great things to talk about in this short workshop. And when it comes to actually using World ID, like what it makes sense for, Sybil resistance and bot resistance make sense for a ton of different use cases, right? The protocol that World ID is built on top of, Semaphore, was actually built with like voting in mind as a key use case. Obviously, social media makes sense, right? Twitter sucks because of how many bots there are. And it would be great if you could know that there is like a real human and this is their account. Customer incentives are one that I particularly like. Netflix used to have their 2-week free trial every time a new account was made. So people just spun up more and more email accounts to get this Netflix 2-week free trial and never ended up paying for Netflix. Netflix doesn't like it when people don't pay them, so they got rid of the 2-week free trial. But with World ID, they could offer a 2-week free trial or even longer, maybe a month, maybe 3 months, knowing that you as a real human only get that one free trial, and then you also get the free trial back just for being a real human. But when it comes to all of these use cases, how do we actually like get these use cases into the hands of people who have been verified with World ID? And that is mini apps. So we recently announced mini apps at a keynote in San Francisco last month. And mini apps are these applications that open inside of World app, where you can interact with World ID and have users verify like they would in an external app, just with a better user experience. They don't have to switch applications or anything like that. And for the first time, external apps not built like by the World project can interact with the wallet in World app. So you can do things like sending payments or even just general transactions, interacting with any smart contract you want on World Chain, our own OP stack layer 2. And additionally, we can give these applications distribution to our millions of verified humans in World app. World app has over 15 million users, over 7.5 million of which are verified at the orb. And your app can be listed in this app store, and if it's especially great, it can be highlighted on the homepage of World app in like a card so that users can hear about your app for the first thing that they do when they open World app. So how do you actually build a mini app? So every mini app is a web view in World app, right? It's essentially a PWA, but instead of added to your app's home screen, it's access through World App. And we built a new SDK called MiniKit, specifically for these mini apps. So something I'm not showing in the workshop, but is like the first thing in our docs that you'll see is actually installing MiniKit. You'll wrap like the main body of your like JavaScript app in the MiniKit provider so that you can access this MiniKit object globally. So to start, let's see like what it looks like to actually verify with World ID in a mini app. When you first configure MiniKit and like set up that provider, it will already have your app ID as you've set up in our developer portal. So for this verify input, we need the action the user is going to verify for in that app, the signal if you choose to use one, right? As an example of what you might actually use that signal for, if your user is, say, voting on a poll in your mini app, that signal might be which poll option they selected, because that signal can't be tampered with between when this verification is generated on the user's phone and when that proof is later verified with our developer portal API or with our smart contracts on chain. So it's optional, definitely not required, but useful in a lot of circumstances. And then this verification level defines which like World ID credential your user is required to have. I've already talked about the orb credential. We see that as sort of the gold standard for knowing your user's a real human with only one account. But there's also the device verification level for off-chain use cases, where World App has checked that it's running a legitimate version of the app on a real phone, not a virtual machine, and that it's not in like an app cloner environment. So instead of knowing it's a real human, you at least know it's a real device. If I want to try to Sybil attack your program with that device verification level, I'm going to have to buy a lot of like $50 Android phones or something like that. So it's definitely a weaker credential, but one that every like real world app user has, whether or not they visited the orb, and is much more scalable. So I've configured all of these things for this action I want the user to verify for. And then I define this like handle verify function here, which I'll just call whenever like the user clicks a button in my app to actually like go ahead and verify with World ID. We'll first just check to make sure that MiniKit is actually installed and configured. And then we issue this async command to MiniKit. So this verify command takes the input we defined earlier. That promise resolves when the user has completed the flow of like tapping verify in the app or declining to verify by tapping out of the modal. And then we get this payload. So this payload will have a status field that'll be like success or error, just to see if the user actually went through with the verification or if there was something that prevented them from doing it. And then we take that payload and we have to verify that proof, right? So that payload actually, also has the success field. This is ripped from an older workshop, sorry. But it has that success field or error field, and then this is the actual zero knowledge proof that was generated on the user's phone. The Merkle root is actually like the root of the tree that the user generated that proof against, right? Gotten from Ethereum mainnet. The nullifier hash is the identifier of that user in the context of your app ID and action ID, right? So if I try to do the same action twice, I generate the same nullifier hash, which is how we actually implement that Sybil resistance. But if I do two different actions, there's two different nullifier hashes, and there's no way to tell that those two nullifier hashes actually belong to the same real human. And that's how we have this privacy, where it's not revealed which user is verifying, just that one of these real users is verifying and only doing it once. This proof is this very long hexadecimal string that's mathematically like the zero knowledge proof itself, and then which verification level that proof was generated for. So in this example, we'll verify this proof with our developer portal API. So you'll define a route on your app's backend that will receive this proof. So here we're just passing that proof, the action, and the signal, if you used one, to your backend. And if that backend function that I'll show in the next slide, does verify correctly and your backend returns this positive response, then you should just go ahead and like redirect the user to the next page because you know they're verified now, or else show them some sort of error. To actually verify your app in the backend, we have this helper function called verify cloud proof that will take in the proof, the app ID, the action, and the signal, and handle calling our developer portal API to verify that proof. So you'll either get this successful response or an error response. If it's successful, in your backend is where you should like mark the user as verified in your database or something like that, right? But you want to like take some action with that successful result in your backend because your backend is the secure context. If you were to just pass that successful result back to your front end and then like try to mark the user as verified from there, right, and make another call to your backend to like change the database or something like that, the user would be able to manipulate that information in the front end so that even if they verified unsuccessfully, they can then just change it to say it was successful. So you have to like keep certain things within the secure context of your backend. But this is like literally the whole like backend code here. It's super simple. But you can also verify these proofs on chain. So in your smart contract, right, in this example, let's say there's just one like action for your whole app that the user wants to perform. In your constructor, you'll pass in the address of the World ID router. You can find that in our documentation for World Chain. Is supported on other chains, but for mini apps, you can only use World Chain, so that's all I'll talk about here. And then you'll pass in the app ID and the action ID. So we'll have this World ID as just like the instance of the World ID router contract. This external nullifier is a combination of the app ID and the action ID. That is what actually determines like the uniqueness of an action. It's more of an underlying protocol thing that's just needed when you're verifying these proofs on chain. So just rip that code from our templates that I'll show you later and reuse it. You don't need to modify it or worry about it too much. And then in this function, which is just verify and execute, right? What you're actually executing is sort of undefined here. That's up to you. We'll pass in the signal, the Merkle root, the nullifier hash, and the proof that we got from that like proof object when the user verified in your mini app. You'll note that we don't take in the verification level here like we did for the backend verification, and that's because only the orb credential is supported on chain. That device credential is not supported on chain. So if you want to do that device verification level, your app has to be off-chain for that proof verification. So the first thing we'll do when we get this proof in our smart contract is check if we've seen this nullifier hash before. So we'll have this mapping of nullifier hash to a Boolean. That nullifier hash is a 256-bit unsigned integer. So if this nullifier hash already maps to true in that mapping, then we revert with this invalid nullifier like event. And that just means the user's already done this action. We don't want to let them do it a second time. If that isn't set to true, the user hasn't done this action before. So then we'll continue and call the verify proof function on the World ID router smart contract. So we'll pass in that root. The group ID defines like which credential we're working with. For the orb credential on chain, that is always 1. We will hash the signal in a specific way for that verification with the smart contracts. That hash to field helper function is defined in our templates as well. We pass in the nullifier hash, the external nullifier that we set in our constructor, and then the proof. If this proof doesn't verify for whatever reason, maybe the signal didn't match up with when that proof was generated or something like that, this will revert. Otherwise, it simply continues. It doesn't return anything. So you already have that like flow control there built into this verify proof function. So if that doesn't revert and continues, then we should make sure that we mark that nullifier hash as used to prevent the user from doing this action again in a separate transaction. And after all of that, that's where you should put your logic of what you want to allow the user to do behind World ID. That might be minting a token to them. That might be claiming an NFT. That's totally up to you. That's what's up to your application. But you should verify the proof at the start of this function, and after that proof is verified and the nullifier hash is marked as used, that's when you go ahead and do the thing that requires World ID. And how do you send these transactions with MiniKit? So, as I mentioned, with MiniKit, everything happens on World Chain, our own OP-Stack L2. And in World App, we have some like fancy functionality for covering all the gas of our users' transactions and batching all of them together. So you can't send these transactions with typical tooling like WAGME, for example. But we have this send transaction command for MiniKit. And when you want to send this transaction, similarly as earlier, because it's an async command, that promise will resolve when the user actually like completes the flow, either tapping send transaction or clicking out of the modal. You'll specify the address of the contract to interact with on World Chain. You'll have the ABI of that contract, which you can either import or just define inline if you really want to. You'll have the function name, right? Verify and execute as we had in our contract. And then you'll put in all of the like arguments for that function that you're calling. So in this case, for verify and execute, we have the wallet address of the user as the signal. We have the Merkle root, we have the nullifier hash, and then the proof you have to like split up into an array of 8 256-bit unsigned integers. It's a little wonky, but again, you can just use the code from the template that we'll provide. So sending transactions with MiniKit is fairly easy. One thing to note is that if you want to have a transaction that involves sending a token that isn't ETH, you do have to use permit to. Our documentation will go into this because for the user experience, we'll have you request the permit to in the same like send transaction command. And then on the World App side, it's actually just one like tap for the user to send that transaction that will generate that permit to signature and then send the transaction with that signature included in order to allow those tokens to be transferred by the smart contract. So that's sort of like the quick rundown of how to build with a mini app. We have 20K worth of bounties available, and we're giving $10,000 to the best mini app. $5,000 to second place, $2,500 to third place. We are all in on mini apps at this hackathon. We want to see these mini apps get built in this 36 hours and ideally be shipped to the mini app store in World App. We want to see these real things be built that we can put in front of users and show them what they can use their World ID and their funds on chain for. We're committed to providing support after the hackathon to help you polish and grow your application. And Leighton, will you raise your hand? He does ecosystem for us. If you really want to chat about a lot more like stuff you can do with mini apps, he's a great person to talk to about everything that isn't a technical question relating to mini apps. That $2,500 pool prize will be split equally among all projects that submit for our bounties and make a good faith effort to build a mini app, but don't receive one of these larger prizes. And all the documentation you need for mini apps you can find at docs.world.org/mini-apps. And thank you so much. We got a question here. So he was asking if you need to be a verified user in order to use the app. No. So you can download and install World App without ever verifying at an orb, you'll have that device verification level, right? You can still use the wallet, you can still use the mini apps, but if a mini app requires that you verify with that orb credential, you won't be able to verify for that specific thing. But you can still use all these mini apps, you can build all these mini apps without verifying. We do not have any Rust support for mini apps, to my knowledge, at the moment.
Is there a way for for your application for WorldCoin to know if a person is registered anywhere? For example, if we are installing anything, a person is registered, yes or no?
So wait, is the question if like? Will you just repeat the question? I'm sorry.
Say from say you are using an orb and you are verifying that you're yourself, but you don't have your cell phone. Is there a way to verify that that person has already been onboarded into WorldCoin?
So, to make sure I understand it, the question was like, if someone doesn't have their phone with them, is there a way to verify, like, with the orb that that user is already orb verified? Not for your application. Like, the orb will reject a second verification for that user, so they wouldn't be able to verify again, but your application can only like verify that that user has a world ID when they can generate that proof.
Okay, I think my question. Okay, better way to explain my question. Can I know if a person has been registered to WorldCoin or not? Or not?
The way that you can know if that user has been verified or not is by making them like verify and generate that proof, and then your app verifies that proof. Correct. You can only prove that you are verified. You cannot prove you are not verified. Any other questions? One more here. How hard is it to set up a new orb station in a country? So today, Tools for Humanity manages orb operations for most of the world. Next year, we'll have this community operator program where people will be able to like buy or rent an orb to operate in their local communities. We announced that at the keynote in San Francisco last month. Still fleshing out a lot of details there, but it will be easier to bring orbs to new countries starting next year. Thank you all. Yeah. No. It's. Yeah. Hi.
working or no? I'm normally very loud, so I can't tell. Are you sure? Hello? Okay.
Okay, and you just drag whatever you need there. Okay, but most of the guys wanted to have it mirrored, like that.
No.
Okay. Okay, nice.
All right, hello everybody. My name is Ali Siraj, and today I'm going to talk to you about, yeah, you specifically, about finding your flow state. A little bit about my background. I do DevRel and product at the Flow Foundation. Previously, I was in that startup hustle. I was a software engineer and studied computer science, even though I might not sound like it. And I started a bunch of DeFi protocols and did consulting along the way. If you want to follow me, it's Ali Siraj0, because there's a lot of copycats out there. I was the first on X. I'm going to start off with a question. And I want you guys to shout because it's a little bit loud. What makes games and applications meaningful? I'm going to pick on you guys if, your lips are moving. Fun, okay, all right, what else? Community, what else? Unexpected situations, all right, some randomness in there. One more. The boys? The boys, yeah. The boys make everything funner. Even like a crazy trip to Bangkok that you almost die on a motorcycle, like if it's with the boys, it's memorable, right? What do you guys think one of the oldest recorded games in history was? Close. Dice was used in the game. It was a game called Senet, and it was about 5,000 years old. We see it in ancient Egyptian hieroglyphics, and it's the oldest one that we're aware of. Games are an integral part of human life. They've existed before written history, and the game of Senet had essentially two players. They had special squares called the Fountain of Life and the House of Wisdom. And these squares, when your pieces would land on them, would give them specific buffs. The whole goal, you have an opponent and you're trying to get your pieces to the other side of the board before them. And it incorporated aspects of randomness, like you could use dice or sticks that you threw. And long story short, it kind of summarized your journey through this life and the next life and the afterlife, right? One very interesting aspect of this game that continues to today is that it created magical circles. Every game creates a magical vortex where there are new rules that are introduced that only exist in that time-bounded time frame and environment. For example, I was talking to Brian earlier today, who has an amazing background in games, and he was describing how, you can't just run and tackle someone on the street. But when you're in the magical circle of American football, that rule is bent. It's acceptable in that time and space, right? It creates a new force field almost where anything could be possible in that environment. Games also elicit emotional responses. They incorporate replayability and randomness, which that gentleman said over there. They're easy to play but hard to master, and they create value. One of the most important ingredients, I believe you said at the very start, is they're fun. Fast forward about 5,000 years, and our technology has changed massively, but these core things haven't. With the advent of the internet, there was a massive wave of global digitization, right? Connecting people and information in ways that were never possible before. All of a sudden, you weren't limited playing a game to the people that were in your direct vicinity, that were sitting across from you, all of a sudden you could play games with millions of people worldwide and exchange common goals, exchange information, and beat the horde if you're into World of Warcraft. The Web3 revolution came about to disrupt something that was broken and not flowing in Web 2. Companies kept their code private and proprietary, digital assets were infinitely copyable, yet you didn't really have control or any ownership of anything you had, even your money, right? Everything was centralized. The Web3 revolution promised a new ethos, true ownership, and offered to solve problems in human coordination. People were starting to get their power back. But everything at the beginning of blockchain revolved around finances. Where was the fun? One day, everything changed. Cats. The ancient Egyptians loved them. We still love them today. At an ETHGlobal event, about, when was 2017? About 8 years ago. Very similar to this ETHGlobal event right here in Waterloo, there was a team that had a question, had an idea. What happens if we put cats on the blockchain? It started off as a fun experiment. Let's have these genetics. Let's allow people to breed these cats, and over time they could have digital collectibles of them, and they could trade them. All of a sudden, thousands and thousands of users started purchasing, collecting, and breeding these kitties, these crypto kitties. All of a sudden, the entire Ethereum network ended up getting throttled. People were like, who the heck are these crazy cat people? Why are they breeding cats on it? Who's putting cats on a blockchain? These images shouldn't be here. Gas prices were absolutely blowing up. What that revealed was there was a massive scalability problem in Ethereum. It's the reason we're all here. It's what started everything, right? And so what ended up happening was all the conversations we hear about L2 stemmed from this. The team behind CryptoKitties came together and discussed, what does the future look like? They looked at 200 white papers that were from the cutting edge for decentralized technologies, and they essentially came up with a solution to make things flow again. Before I get into that, I want to start off with a story. Imagine that your friend, who is a complete normie, comes up to you and says, oh my God, like there's this amazing application. Maybe it's a decentralized social application or a game. You absolutely must play. And the first thing that you do when you go to that game, that decentralized app, what's the first button you're going to see in the top right corner? Connect wallet. And they're like, what the heck does connect wallet mean? Like, am I connecting my physical wallet? I don't have a physical wallet. Is it Apple Pay? Whatever. I'm going to click that. The next thing, okay, I have to download a plugin from the Chrome store. That's kind of sus, but sure, whatever. I'll trust this. Wait a minute. Now I have to memorize a sequence of like 14 words. Okay, no. You cannot save it on your computer. You have to write it down on a physical piece of paper because it's way too valuable for you to lose. Wait a minute. If I put it on paper, it's more losable than, okay, whatever. I'm gonna do that. As soon as you authenticate and go into the app, you try to do a transaction. You try to do one simple action. What's the next thing that's going to pop up? What the heck is gas? Is that online taxes? Like, okay, where do I get that from? I start Googling. I go to a centralized exchange. If you're in Canada, like I'm from, and that fellow over there, sorry for doxing you, brother, you're essentially going to be on a call with the fraud department at your bank for 5 hours trying to convince them that you're not getting scammed. If you're able to successfully do that, which you're not, then you might be able to enter the app. More likely, you're going to feel like a drug dealer messaging your friends, hey man, can I interact you some cash for some crypto so I could play this game? That is a terrible experience, right? Flow, at the protocol level, gives builders the tools that they need to remove all these barriers in using and creating Web3 apps. Before I get into how that's done, let's discuss what exactly Flow is. Flow is a layer 1 blockchain with ultra low gas fees that first launched its proof of stake protocol in 2020. It was co-founded by Dieter Shirley, who is one of the brightest minds, and he coined the term NFT, right? Now, there are currently 2 virtual machines that run on Flow. One is called Cadence and the other is EVM. meaning that Solidity contracts and popular EVM tooling like Hardhat, Alchemy, Brownie, Open Zeppelin contracts, Remix, they all work off the bat with zero configuration needed. Flow is also the home of many consumer applications that house some of the world's largest and most energized communities. One of the first applications that launched on Flow was NBA Top Shot, and that ended up bringing in millions of people, hundreds of millions of dollars in revenue. Most of the people didn't even know it was run on a blockchain, right? And then after that, Mattel was like, hey, you know, we wanna add Barbie and we wanna add Hot Wheels, and then Disney was like, hey, we're gonna launch Disney Pinnacle on Flow. If Barbie's gonna be there, we need Disney princesses, and we also need Star Wars. So massive communities ended up forming on Flow, but it wasn't until literally 2 months ago that we became EVM equivalent and are seeing a huge explosion in games, in DeFi and the likes. But what makes Flow unique for building fun applications? To build these kind of applications, especially the type that could incorporate millions or billions of users, you need really extremely powerful architecture that can scale with the billions of users that come and the data that they generate. Flow allows for the storage of massive amounts of data, and our goal is to allow a single user account to store over a petabyte of data. Flow approached the scalability issue with a unique multi-role node architecture that essentially scales horizontally. Think of it like a Ford assembly line. Instead of all of the nodes doing the exact same tasks, you have hyper-specialized nodes like access nodes that are only responsible for accessing data on-chain. Or you have verification nodes, consensus nodes, execution nodes. They're all focused on just one thing. And that allows for scalability without sharding. Putting this tech jargon aside, it allowed applications to be built like NBA Top Shot, which, for those that don't know, it essentially allows you to have these video clips as NFTs in NBA history. On certain days, that one application generates more transactions than the entire Ethereum network, showing and proving to all of us that there was a way forward for scalability, that you could get to the level where a single app could scale to the level of entire chains. I'm going to introduce just 4 unique features of Flow that unlock apps. First, Flow offers a unique account and transaction model, which EVM developers can leverage through Cadence, which is a Flow native language. This allows for things like splitting up transaction roles between the proposer, the payer, and the authorizer. And you don't need a paymaster contract. Essentially, the app can pay for transactions that the user proposes and authorizes, essentially creating fully approval-less and gasless experiences for the end users. This is extremely important for social applications, extremely important for video games and the likes. Flow also supports at the protocol level account abstraction and something we call account linking. This makes it possible to create apps where users can sign up using their regular Google authentication and a wallet is created in the background that's managed by the application itself. Transactions can also either be bundled or the app can even manage all the approvals so you don't have to sign a single transaction with every action that you end up doing on chain. As an end user, you can get all the benefits of using a decentralized app without any of the crappy UX. Second, Flow offers protocol-level VRF, or a verifiable randomness function, which allows apps to use provably fair random number generators. You don't need to rely on a third-party platform or oracles. Within one line of Solidity, you can access a random value from a range directly from the protocol itself. This is super useful for things like dice rolls, attack damage, gaining experience, and the majority of game mechanics that we see every single day. Another aspect that's super unique on Flow is attachments. So taking a step back, everything is inherently open source in Web3, meaning that when you solve a problem once for one specific issue, it's solved for everyone at all times. And you can move to the next problem that needs solving. This allows for composability, which is essentially the compound interest of innovation. Attachments allow developers to add additional data and functionality without the permission from the original author. They're kind of like modding for Web3. An example that I would give is Skyrim. How many people have heard of the game Skyrim before? So Skyrim came out almost a decade ago, but similar to Warcraft 3, they created a modding editor, or they created an editor where people could create mods on top of their base game. If you look at websites like Modding Nexus today, you will see literally 5-6 billion downloads of mods that are being created literally to current times. And some of these mods are doing things that weren't possible a decade ago. They're doing things that the original creators couldn't have even imagined. One of the mods that I was looking at mixes Whisper AI with OpenAI's API so that when you talk to, you could literally talk into your microphone to an NPC that you meet. It will take those words you're saying, convert it to text, takes that text, put it into like OpenAI's API, take the result, turn it into speech, and the NPC will literally talk back and forth with you about anything in that world. All of a sudden, you don't have these two-dimensional characters anymore. You have almost lifelike creatures. This is something that wasn't possible when Skyrim first launched. It's something that, because they made their game inherently moddable, created more value propositions beyond the original creators' concepts and brought in, to this day, more users into the Skyrim game, right? And this is something that easily extends to Web3, easily extends to creating composable experiences and applications and contracts. And attachments make it very easy to attach additional information and data to them. You could think of capabilities as detailed permissions and granular access control, almost like AWS IAM if you're familiar with it. You could revoke, limit, or grant access to assets, functions, and resources. For games, this could apply to almost everything from making comments to community permissions for your guild to literally allowing someone to, like loaning your sword or armor or gear to someone for a specific amount of time and under specific restraints. All right, enough about the tech. Where is Flow today? We just launched the world tour where we were in previous cities like Singapore, where we focused on consumer DeFi, San Fran, where we focused on sports, and Chiang Mai, where we focused on decentralized social. Right now, we are in Bangkok and focused on two key themes for this hackathon. One is the next killer app. And I'm not talking about, Skynet or like anything like that. I mean the best consumer application targeting real everyday people and solving real problems. You could think about it almost like we've had AI around for many, many decades, but it wasn't in the hands of everyday people. They couldn't access its benefits until, it's crazy, it feels like much longer ago, but it was almost a year ago that ChatGPT ended up blowing up and became the fastest adopted product in history. All of a sudden, that consumer product unlocked the value of AI for billions of people. Your grandmother could use it for recipes. You could use it to help you with coding your application. Your brother could use it to figure out if they just poisoned their cat or not, right? You could use it for like literally anything. So I want to challenge you guys, if you're going to be hacking on that stream, to think about what is the next consumer application that solves a real problem that can literally give the value propositions and benefits of blockchain to as many people as possible. The second one is the best game. We're especially looking for Telegram games, but it's a much broader category overall. So thinking back to some of those core characteristics that I mentioned at the very beginning of what makes an experience meaningful. How could you create games that create their own circles and warp fields and invite their users in with that randomness, with that replayability, that social aspect that connects you to the boys, right? We also have two other streams. One is for the best overall developer feedback, and the other is for giving feedback. These are rarely applied to, so I highly recommend you challenge yourselves to put in some feedback there. We're all about Kaizen and continuous improvement. This could be anything from, hey, this documentation is missing, or I think that this could be reworded, or this type of SDK integrating would be super valuable. When we look at the hackathon that we did almost 3 weeks ago, how long ago was ETH Singapore? My brain's getting warped. 3 weeks or 4 weeks ago? Huh? September. Okay, so a little bit over a month. So back in September, during ETH Singapore, there was one product that wanted to make, or one team that wanted to make a consumer-focused pump.fun application. And they wanted it to be as rug-proof as possible, requiring people to authenticate with Twitter. They won one of our DeFi streams, and within a little over 4 weeks, ended up going live on mainnet. On their first day of going live, they generated over $1,000 in fees and had over $100,000 in assets going into the protocol and being traded, right? One of the reasons for that is we've created an ecosystem storefront where if you create an application that goes live, there's the possibility of putting it in front of millions of prospective users and solving one of the biggest problems new applications suffer, which is getting their first users, right? And if there's one thing I want you to take away from this talk today, it's that over these next 3 days, you might be hacking on something that you think is a fun idea, or learning a new concept, or mixing and matching different technologies, but you really have the power to create something that will impact millions of people and go live. And I want to challenge you to do that. Flow has ultra affordable gas fees to the point where virtually all mainnet transactions are sponsored by the Flow wallets, like the primary wallet in the ecosystem, right? Try launching something on mainnet and see where it goes. If you want it to come to life, if you want to put it in front of real people, we're here to help you make that dream a reality. So with that, I will end with, let's go with the flow. Does anyone have any questions? I believe we have about 5 minutes. My man. Is the randomness compatible with Solidity?
So there's the 2 virtual machines, right? There's the EVM one, and then there's the, what's the?
Yeah, so the consensus mechanism, as you saw in the really neat graphic, is a little different with Cadence, and so pre-Randau isn't used. And so instead, we just feed the native block-by-block VRF into that. Okay. So if you just use pre-Randau, the same that you would before, it's actually unique to that block and its new meaningful randomness. If you're doing something really, really high stakes, there's a couple of additional things you would want to do with security, but for almost every use case, it's verifiable randomness, more than enough for anything, any game, any app, anything like that.
Okay, cool.
Just let the questions go with the flow, guys. Channel your inner flow state. What game am I most excited to see come on chain? Oh man, everyone has different tastes in games. I am really bullish on games like Crypto the Game, where you have these characters, the social experience. It's almost like Survivor, right? Where every single day you have to vote people off. You have NFTs representing each of the characters. I would personally love to see more like Web3 games around that, mixing like zombie apocalypse themes. So maybe every night you can go on a raid and you use on-chain randomness for a percentage chance that you're gonna get loot. But then there's also danger, and you could have a composable NFT using attachments where maybe you get scratched, or maybe you lose a ligament, or like your character gets a scar, and that NFT updates when you go on these raids. And like you could form communities and you could attack other people. Like I really like those kind of like werewolf type and like social and like zombie apocalypse themed games. So something that mixes all of those things together, I think would be badass. Yeah. Anyone else? Oh.
Hey, so why hasn't on-chain poker really caught up and like made a big splash on the scene? Because like I'm thinking like bringing poker on-chain is like a no-brainer, but I haven't seen any such use case to date. It's mostly off-chain, Web2 poker online.
That's a great question. I'm not entirely sure. Oh, do you want to answer that, Brendan? Oh shit. Okay. Because I think this man might have been working on just that.
Oh yes.
Yeah, we actually have a roulette launching on Flow very, very soon. But one of the biggest issues that we encountered legally was there's always a throat to choke when it comes to decentralization. And most of the chains that have a randomness function available to you are VRF, like verifiable random, but they're provided by an Oracle solution. And so those people can still be considered operators of that gambling site. If you're worried about the legality of, you know, your poker game or your roulette game or your baccarat game, then there's always someone that they can go after. And it's one of the reasons why we're seeing like Rollbit that needs to like own their thing and sanction it away from different places, you know, make sure that no one can access it from different places. And that's one of the biggest reasons that you haven't seen poker go off, I think, is because of the legal concerns around gambling in various jurisdictions where you really want to see it.
That makes sense. Thank you.
Thank you, Brandon. I couldn't have done better. Anyone else? All right, just show of hands. Who here is thinking of building a consumer-centric application? Okay, and who here is thinking about building a game? Okay, nice. Anyone want to ask any questions specifically to their, or specific to their application? Or we have about 1 minute left. No? All right, we will end it there. If you guys have any questions, our table is going to be very far in the back there, in the corner. More than happy to ideate, help you guys flesh out your ideas, or even if you need mentorship on how to pitch your presentations at the end. We also have flags that you could take from the table if you want to put them on yours so that we could give additional mentorship. Be sure to join our Telegram chat as well. Thank you guys so much.
It's HDMI coming into this, but what's this thing?
อันนี้คือสายอะไรคะสีขาว
It's for the capture. What's this thing? Do you need that? I think it's their control.
Do you need it?
It is connect with the control.
Can I use HDMI directly or not? Can I use direct HDMI?
This one is connected to their software to control the presentation.
With the streaming. นั่นคือเขาจะเอาอันนี้มาเชื่อมนี้ซึ่งมันใช้ไม่ได้เพราะว่าอันนี้มันต้องเชื่อมกับไลฟ์ใช่ปะอ๋อมันเป็นสายอินเทอร์เน็ตเฉยๆเหรอคือถ้าถอดได้ใช่ปะถอดอันนี้เสียบเลยได้ใช่ปะIt's okay, it's okay. It's okay to use this only. Okay. So let me try and check the technique. ลองไปดูว่ามันได้ไหม
1, 2, 3.
Yeah, it's open.
It's open already?
Yeah. Oh. That's all right.
All right. Thank you, everyone. Welcome to ETH Bangkok 2024. We are extremely excited to be here. We are Quinto. My name is Victor Sanchez, and I'm the CTO and one of the co-founders of the chain. Today, we're going to go through a couple of things. But we're going to start on first, what's Quinto, why is the reason to build on Quinto, and a little bit on the specifics on how to make it work during the hackathon. And of course, we're going to take a look at the prices as well. So let's start on why to build on Quinto. First of all, it's important to understand that Quinto is fully EVM compatible, which means that everything that you already know about EVM, you're going to be able to use on Quinto no matter what. So if you already are thinking on pretending to build an EVM application, you're going to be able to deploy it on Quinto, no issue. However, there are three important things that you need to know if you're thinking on developing on Quinto. First of all is that, yes, and do not run yet, I promise, there is an explanation for this. You have to be KYC or KYB on Quinto in order to both develop and manage the applications. However, and this is really important, this KYC and KYB is never stored on chain, and it's done in the more privacy-preserving way possible. Your information will never be stored on chain. It will never leave the KYC provider that you choose from an initial list of 3, and you will create essentially this Quinto wallet with the Quinto ID, which is a surrogate for that onboarding process, and you will be able to check if an account is KYC'd or not, if it's sanction safe or not in a given jurisdiction, and most importantly, you will be able to do all of that with one line of code, checking those 3 flags that I just mentioned. Another very important thing is that everything on Quinto is account extraction. We are EIP 4337 compatible, and everyone, including you, developers, are going to be creating a smart contract wallet. This smart contract wallet, called the Memory Wallet, will allow you to do several very important things. First, save a ton of gas. In fact, for final users, Quinto is a gasless experience. It means that through the Sponsor Paymaster and our developer portal, you are going to be able to pay for the transactions of these KYC and KYB users, and they are not going to require Ethereum Quinto in order to make those transactions happen. We are going to offer you, however, because we know that it can be daunting, right, to do user operations right away, especially if you have never been touched by EIP 4337 or by a smart contract wallet, you are going to be able to use our Quinto Wallet SDK with just a few lines of code. Finally, you will see that we have streamlined the chain and all its applications for user experience, and this includes you developers. So, if I haven't convinced you yet about why to build on Quinto, let me add 20,000 more reasons on top of that. We are going to be choosing our best Quinto app overall and give it a price of $7,500. And then we're going to open 2 tracks, the Smart Contract API track and the Quinto Wallet SDK track. First and second place, $3,500, $1,500 in both of those categories. Finally, you are a student. Please make sure to let me know directly on your application when you send at the end of the hackathon on Saturday night, and make sure as well to take care of your UX and UI, because there is a special price as well for UX and UI. Finally, I'm going to be releasing before the end of the afternoon documentation for Ben, our integrated security firewall, and we have our partners right there, Joanna, and there's going to be as well for the best Ben integration a price of $500. All right, so without further ado, what is Quinto? Quinto, oh, too fast. That's something that happens with me, sorry. So Quinto is the first L2 developed on the Arbitrum Nitro stack, and we like to say that we are what Base is to Optimism, Quinto is to Arbitrum. Basically, we run parallel to Arbitrum 1 and Arbitrum Nova, therefore we settle directly in mainnet. Our mission is to create a safe space for developers, DeFi and TradFi to engage on. And that's why, and now you are understanding already that KYC aspect of it. Just yesterday, a big TradFi institution from Europe deployed 20 million of TVL thanks to these protections that I mentioned before. Our 2 pillars are security and usability. I have explained security a little bit, but security doesn't matter if you are a new user that have never touched crypto. The dream of Quinto as an L2 is for people to forget that they are using an L2. We will see ourselves as a DeFi super app thanks to that usability prospects that I'm going to be commenting as part of my talk. So Quinto is designed for developers, and it doesn't matter if you are a veteran or you are just starting. What you're going to see is First of all, you have that permissionless and decentralized KYC, KYB. It's still permissionless because anyone can start that process and no one can stop you from doing that. We just have added one consensus rule to the stack, to the Arbitrum consensus stack. We have modified Geth in order to do this, in order to have that guarantee that we know who the counterparty is and which jurisdiction they are on. But once more, that PII will never be transferred to any peer, on-chain, or to any of the partners that you use unless you sign that data. Finally, we are, as I said, fully EVM compatible, and we are not only providing that free KYC that I mentioned before, we are also doing constant analysis for anti-money laundering. We are doing KYT. We are analyzing statically and dynamically every contract deployed and every transaction made. So we are able to freeze those Kinto ID that I mentioned at the beginning in case that a malicious attack or a malicious contract is detected on the chain. This, by the way, allows us to do something that is a very first on the world of L2s, and is that we have partnered with Bridge and Hypernative to offer insurance at the chain level. Every single wallet on Kinto has up to $2,500 against the smart contract hacks insured, and you can buy additional tiers of insurance through the Kinto application. A few differences that are very important. So as I mentioned, right, we are using these smart contract wallets by default on Kinto. This is really important because what happened to EOAs? Well, EOAs can be signers of that smart contract wallet, but EOAs cannot on their own interact with the chain. Everything is a user operation that goes directly to the entry point that we have developed. Therefore, all users need a smart contract wallet. And as part of that onboarding that I mentioned, when you go to the KYC, you also will deploy your smart contract wallet, will receive on the background, thanks to the sponsor paymaster, the necessary gas, and users will experience it as a gasless overall experience. Another very important thing, all users need a valid Kinto ID. The wallet has an NFT, a soul-bound NFT called the Kinto ID, that is the one that stores the flags that I mentioned before. Is KYC, is KYB, is safe in this jurisdiction, and other useful wallets that we will see as part of our API. Finally, basically, these KYC and compliance rules are enforced at the node level, which means that this cannot be hacked through smart contracts, right? Because these consensus rules reside in this modification that we have done at the Geth level. All right. Whoops. Sorry about that. Press the wrong button for a second. Apologies. Let's go back. I'm going to stay here, even though I don't like the stand. So how does it work? Basically, the first time that the user arrives to Kinto, they are going to have to select a KYC or a KYB provider, CNAP, Platts, and we have recently added on FIDO. One that the user completes the KYC or the KYB process, those are going to be stored in the KYC provider, and it checks that PII, but it never leaves, it never stores on the chain. After this, basically, on a successful KYC, we're going to create, through the Kinto identity node, your wallet and your Kinto ID. And not only that, we are also creating, this is a multi-sig wallet, which is really important to offer that level of security that we were mentioning before. But that first signer is a turnkey managed signer that is triggered to either your biometrics, so your fingerprint or your face, or your device itself, or your password manager, if you have it. Once that you have cleared all of this process, you will end up with a Kinto wallet with at least 2 signers, the first one being triggered to your biometrics, a Kinto ID that is cleared to operate on the chain. So let's talk a little bit about the wallet. As I mentioned before, if you are familiar with EIP 4337, this wallet is absolutely compatible with the standard. It's a multi-sig by default, as I mentioned before, and it has integrated these KYC, AML, KYT, and security-based rules. There is also these passkey-based signatures that makes it extremely easy to use. And when you go through the process, you will see that you can do KYC, create the transaction, go against the faucet, deploy your first contract in literally putting your finger a couple of times on top of your laptop. There is another very important thing, as there is no pet eating your 24 words or a boating accident losing your Kinto wallet, because thanks to that KYC system, you can also recover your wallet. I won't mention who lost it already, but we have a user, a very big whale, that lost access to their wallet, and by re-KYCing, they were able to recover the wallet through that recovery signer that we have as part of the Kinto wallet. finally, is that easy and straightforward UX that I was mentioning at the beginning, and that you can experience at engen.kinto.syc/onboarding. Now, everything that I'm going to talk from now until the next 16 minutes is almost step-by-step our development guide. If you go to docs.kinto.xyz and find development guide, you will see, and I promise we stand by our word, a 10-minute setup. That 10-minute setup will imply doing your KYC, setting up your deployer EOA, preparing your environment setup, and finally creating your first Kinto app and using it. And I promise it's exactly 10 minutes. So let's take a look at that process a little bit. First of all, you're going to have to set up your deployer EOA. This is very important. As I told you before, everyone, including the developers, are going to need to have a smart contract wallet, right? However, developers, I'm going to let you cheat. And the way I'm going to let you cheat is basically you can nominate an EOA that you're going to use to deploy and to set up your own contracts. How do you do that? You go to engen.kinto.syc/developer. Don't worry, it's all on the guide, as I mentioned before, so no need to take notes. And just copy and paste the public address of your deployer EOA, set your deployer account, put your fat finger or show your face to the laptop to make that signature, and you're going to have that ready. And you're going to come to the developer portal. In the developer portal, you will see what is your wallet, what is your deployer EOA, and you're going to be able to do two things from this screen, both very important. One, add balance to your deployer EOA so you can operate against those contracts that you are generating. You're going to be able to create new apps. And as you see here, I have already my Victor test counter. So you're going to be able as well to top the paymaster for the test counter. So again, if someone wants to increment my counter, they are never going to require gas, right? Kinto ETH in order to do so, because the paymaster pays for the entire party. All right. 1 second. So how do you create your first app on Kinto? Basically, you are going to arrive, and all of the apps on Kinto, and this is another of the kind of beautiful things of Kinto, is a 721 NFT. So basically, you're going to create this NFT that has a couple of things. Number one, you have all of the contracts that are going to be part of your application. So if your application has one contract, it's very easy. But let's say that you deploy 20, 40, 50 on that piece. So this NFT has a list of all of the contracts that are included as part of your applications. You also can include more than one EOA. Obviously, we mentioned before that you had that ability of having one EOA that interacts with your contracts, but it may be that your security model requires more than one EOA to directly, without the user operation, attack those contracts. You are going to be able to do so. Finally, the metadata also includes the details of the sponsor paymaster. Another of the beauties of having Kinto's apps as NFTs is that you can very easily transfer or burn those applications as part of your development process. So, you know, it hasn't happened yet, I believe, but you could literally sell your application to someone else if you wanted to, which is pretty cool. All right, so the first thing that you're going to do in order to get started with Kinto is you're going to set up our RPC. You're going to get your private key of that developer EOA. Obviously, that never leaves your computer. You're going to, for instance, try to deploy a contract, in this case, a simple counter. And once that you have your counter address, you are going to go back and click on that new app button that I told you before. You are going to key in here the address of your counter. And then you're going to be able to establish rate limits for who can use your paymaster and how. Obviously, there could be DDoS attacks, right, against your paymaster. So you want to make sure to know, hey, what is the gas limit per amount of seconds, or what is the number of requests that each of one of those addresses that is using my app can do. And of course, you are able to charge as part of your application whatever you want. But the gas for those transactions are going to come for what you top tap on your application in the developer portal. So, okay, so once that the app is created, now you can directly start working with the wallet SDK. So as I mentioned before, this can be kind of challenging, right? If you have never sent a user operation before, doing that UI and preparing and packaging those user operations to the entry point could be a little bit challenging. However, we have prepared for you this Kinto Web SDK. Download the example and take a look at exactly this. You're going to need to put your app address, in this case, the address of your counter when you start as part of the guide. And you're going to call to the line, create Kinto SDK with that app address. Once that you call it to the connect method, you're going to be able to start sending transactions. And those transactions, those user operations, are going to be as easy as, let me know where are you sending that transaction to, in this case, the counter address. Let me know the value of that transaction, one anything way if you want to, and the data in hexadecimal that you are sending. From that moment on, the SDK takes care of everything else. And this, by the way, is an array. You can send as many user operations on that transaction as you wish. Once you have it, Kinto SDK.send transaction, and you have a wonderful promise on the other side to either have the successful hash or an error coming from here. If it's the first time that they connect, they are going to need to do the same thing that you did, going through that process of doing the KYC, creating their wallet, etc. How do you do it on your side? Extremely easy. Call to Kinto SDK, create a new wallet, and you're going to trigger that process on your web application directly. So there is a React SDK example that we have done that integrates already my counter, so you can test it and increment it. And you can see kind of all of the methods that are part of the Kinto Web Wallet SDK. So you can just download the React SDK example. Again, all of those links are in the guide that I mentioned at the beginning. Click on Yarn Install, and you're going to be able to get those packages. As I mentioned, one of them, the Kinto Wallet SDK. Make sure that you create a valid SSL certificate for your project in localhost. This is important because as part of the passkey, you require SSL to make those signatures work with the passkey. So it's really important that you don't miss this step. It's just 3 lines, but without this, it won't work. And on the previous hackathon, I went through over this with like 20 teams or something like that. So I added this slide. Please remember to create the SSL certificate before getting started. Once that you have it, make sure that you add that dev.kinto.xyz or whatever you are calling your application, redirect into your local host. And of course, it needs to match the SSL certificate that you just created. Once that you have that, you're going to start, and you're going to be able to start editing this. You will see that the files by default are called dev.kinto.xyz pm, dev.kinto.xyz key.pm, and you have them directly in your package.json. If you have another name, make sure to edit them. Make sure that you put your contract address on the app transaction. And when you have it, you will be able to see this. You will click on Login Sign Up. That will connect your Kinto wallet. Once you do that, you will be able to increase the counter and send the first example user operation. As I mentioned before, well, it's, as you see, this counter increases. This is my application. I will be paying for a lot of gas for all of you to pay those increments, but play around. Feel free to try to hack my app or try to type my sponsor paymaster rules, see if you can break it. All right, there is as well a smart contract API, and as I mentioned before, a smart contract reference. So if you go, a smart contract tracks and prices as well. Go to smart contract reference on docs.kinto.xyz, and you will find a lot of very useful contracts. I recommend that you start in one called the KYC viewer. The KYC viewer has very useful methods like, is this address, which is my wallet, an individual? Yes or no. Is this KYC? And you will see that there are others like, is company? And you will see others like, is sanction safe, etc., etc. So you can make very useful applications. Like for instance, Dinari, I don't know if you are familiar with them. They do stocks on chain. They have deployed on Kinto, and they use these methods to determine if you can buy US stocks or Canada stocks on Kinto. Can you hold Tesla, yes or no, depending on some of these flags. And this is one of the examples that we have in here. So, a smart contracts API, I'm not going to go into detail in there because our time is limited, but basically, remember that the idea is exactly the same. You have these user operation arrays that you're going to create, and once more, if you have never created a user operation, what you need to know is that our Kinto core repository includes helpers that will allow you to create user operation at the smart contract level with a helper that is extremely useful. Give me the blockchain ID, give me what is the source and the destination, give me the value, give me the nonce, give me the private keys that are on that array that we show at the beginning, and then encode with signature whatever you want to do. You are going to start always with whitelisting the app on the wallet. That is another of the security features that Kinto has. But then the next transaction is going to be one more, create user operation, and the only two things that you need to care about is increase the nonce, and then call increment into this case. So again, you can decide to do that with the very easy to integrate Web Wallet SDK, or do it directly in your smart contract. And there are different tracks, different prices, and different benefits to both options. Finally, as I mentioned before, all of this is in docs.kinto.xyz. You have as well that development setup. These are all the links that are going to be available as well in there. But if you are watching this online or you are watching it after the hackathon, you will have a reference always on this spot. We have a very active developer community on Kinto, so make sure that to join not only the ETHGlobal Discord, but discord.com/invite/Kinto to talk with our community of developers. And I want to finish, and hopefully I have a few minutes for questions after this, but I want to finish mentioning something extremely important. I have been working together with my two co-founders and an excellent smart contract developer now for almost 7 months to put together a lot of stuff. You have the stack, Arbitrum. You have the infrastructure. Caldera is our infrastructure, sorry, our chain as a service service. You have things like Netlify for the website. You have Fauna for the things that we cannot put anywhere else. You have RPC nodes like Nodis, Anchor, and QuickNode that give you global access wherever you are with a fraction of a second. You have security with Hibernatives, chain analysis, iron blocks. You have KYC, KYB, and AML providers integrated in this chain. Whoops, there we go. You have things like the data availability layer. You have the sequencer, decentralized sequencers, explorers like BlockScout. You have the bridging that goes through Socket and allows you to do chain abstraction and do swaps with other chains. You have the bundler with Pimlico. You have an on-ramp with Coinbase. You have turnkey utils and wallet through Dynamic Chain, which allow you to do things like connecting your Twitter account as a signer. The reality of it all, though, is that none of this matters. The reality is that all of this is work that we have done for you, the developers, because we believe that the killer application is not any of these features that we have hammered our way through to make this chain possible. The reality is that we are here today because the killer app is going to come from you, not from us, and we are really looking forward to see what you guys build with them. With this said, thank you. Welcome to ETH Bangkok 2024, and I'm looking forward to see what you build on Kinto. All right, that's a record for me. I'm a Spaniard. My DNA doesn't allow me to summarize or to speak slow. So yeah, I have 4 minutes for questions. So if anyone has a question, I'm very happy to answer. Any questions? All right.
Hello. So I want to ask, is the smart contract APIs is compatible to other EVM chain?
100%. All of our smart contracts APIs that I show you on that reference, they are EVM compatible. Everything is Solidity. So if you are, if you have contracts for your application in any other EVM chain, you can literally take the same contract at one line. If is KYC, if is sanction safe in this jurisdiction, and you are done.
Okay, thank you.
Of course. More questions if you have them. 2 minutes. If not, do you have an idea? Do you know what you're going to build on Kinto? If you want to pitch it, this is the time. Please, yes. Can we? Yeah, thank you so much.
So my question is, does Kinto support those Omni solution like Layer 0? Because you guys using the account abstraction, right? So I don't know if it's, when we implement that, if there's going to be any issues. Have you tried that?
So right now, Layer 0 is not connected to Kinto. We use, however, an alternative solution from SuperSocket. It's called the Super Bridge. You can take a look at the documentation as well on our docs. But if you have any questions, I will be at our booth, and I can help you out doing, any cross-messaging chain. Any cross-messaging message that you need to send, or if you want to bridge items, I can help you out with that.
Okay, thank you.
Of course. Any other questions? 60 seconds. No? All right. In that case, thank you very much. Enjoy the hackathon. And yeah, I hope that you sleep more than what I'm planning to do. But I think, yeah, all of you won't sleep at all. Have a good one, everyone. Cheers.
Okay. Yeah, yeah, yeah. Oh, I see. Okay. Yeah, I'm good. I'm good. Your turn.
Hello, hello. Welcome, everyone. Ready? Yes. So welcome everyone, and we are from Chainlink Labs. We are here to talk about not only cross-chain applications, but all the Chainlink services. And this is me. My name is Saul, and these are all my contact. Feel free to contact me later, and we are also in the booth. And
Yeah, my name is Frank, and I am, as a soul, I am a developer relation engineer from Chainlink Labs. So, yeah.
We skip?
yeah, yep.
Hi everyone, my name's Harry. I'm also in the DevRel team. I lead the DevRel team at Chainlink Labs and very happy to be here and very happy to connect with you all.
And by the way, talking about Chainlink bounties, can you see that I have a phone here? An amazing phone.
Headphones.
And yes, headphone, yes. And this can be yours if you are our winner. So Harry will explain the bounties.
Sure. So Chainlink actually has 20K in bounties as part of this ETHGlobal, so it's a top sponsor. And we've split our bounties into two categories, right? Because Chainlink has as you're going to find out soon, there's a whole bunch of developer services. We have $4,000 for the use of Chainlink CCIP, which is our cross-chain interoperability protocol. So anything you do in the cross-chain space as part of your project is eligible. We have 3 projects, 4K prizes each one. And then for all of the other services, we've bundled them together into 4 prizes of 2K each. So it could be data feeds, data streams, proof of reserve, functions, automation, VRF, deco, anything you want. So, and other than those, if you're a prize winner as one of those bounties, as an extra special prize, you get, everyone in your team gets a pair of branded Chainlink JBL wireless headphones as well. So a little extra incentive to incentivize you to look at Chainlink and consider Chainlink as part of your project.
And for everyone that is here now in this room, in the workshop, you can get these pants, okay?
Yes.
Yes.
And you get pants.
So go over there after this and you can have your pant. And also, what about the other blockchains? How can you use Chainlink with everyone that we have here, Harry?
Sure. So there's obviously a lot of sponsors here, 70 sponsors. Chainlink fits in and integrates well with many of the other sponsors here. So we're on multiple blockchains other than Ethereum. So if you're considering these, some of these chains here, you can use Chainlink services on those chains and you'll be eligible for prizes for Chainlink as well as the blockchains.
Not only blockchains, what else do you have?
Yes, so there's other developer services or developer platforms as well that actually fits in really well with Chainlink as well. So Uniswap hooks, you can create Uniswap hooks that use Chainlink services, and if you come to us at the booth, we've got some really cool ideas we can share with you on that. Circle developer platform in terms of programmable wallets and the smart contract platform as well. The Chainlink services really fit in well with that too. And the graph fits in really well with Chainlink as well because you can use a product called Chainlink Functions that you're going to hear about soon to actually query subgraphs off-chain and then pull that data back on-chain and do all sorts of interesting things. So there's definitely a lot of synergies with some of the other sponsors here and Chainlink where you can be applicable for prizes with those sponsors as well as Chainlink.
Yes, amazing. So this is our presentation now. So everything that we are talking with you, it's here. So it's your moment, get this QR code, and remember that you can own these headphones as well. You can have pants, And all for you.
And 20K in prizes.
Yes, this is amazing. And also, remember, we can get our prizes in the other ones as well. Woohoo. All good? Yes, let's go. So talking about so what is Oracle? Um, you need us to connect with the world. This is the key. So we really need to use the oracles to be connected with everything that you need. Like imagine that you have data from financial services or for temperatures or for everything. So we need this to connect with everyone, okay? And when I talk about the oracles, it's so important to be decentralized because the way you are bringing the information is the key. So you must be sure that the information is not compromised. So be decentralized can be better for you. And when we talk about the services that we have to offer in a decentralized way, first is all related to data. So data feeds, data streams, and proof of reserve is the way that you can get quotes and especially numbers and using our smart contracts. You'd like the quote of ETH in USD, or you'd like any other kind of quote or proof some reserve in a bank, you can use all of these services. Also, we have the computing services. They are VRF to generating random numbers. Also, automation to call any function that you have inside the smart contracts with the rule that you need, like can be time, it can be related to an event, or can be related to your business rule, you can. And also you have DECO that was calculated. It's the first time that we have it this year. Wait a minute about DECO. And we have CCIP that there are the amazing prices in bounties as well. So what's CCIP? We are talking about the Chainlink Cross-Chain Interoperability Protocol. And Frankie, can you tell me about what you can do using CCIP?
Yeah, so before I introduce more about CCIP, I just want to give the definition about the cross-chain. So cross-chain is actually a very new concept. It was introduced into our industry like 5 or 6 years ago. So we first think about the cross-chain. So first thing come to my mind, at least, is to cross a token from the blockchain A, we also call it a source chain, to the blockchain B, and we also call it a destination chain. So by doing this, we can just move our funds from the source chain to destination chain. But when the business logic is becoming more and more complicated, and we want to just not only move our tokens, but also we want our tokens to be executed, or we want to send some instructions to the destination chain as well. So in this scenario, we kind of bind the tokens with the instructions and wrap it into a arbitrary message, and send this message from the source chain to the destination chain. And that is called the cross-chain interoperability for the arbitrary message. And by doing this, you can actually send a cross-chain transaction. For example, you can deploy the NFT smart contract on the blockchain and also send a mint function from another blockchain. And the NFT will be minted under your address on the blockchain where you do not have any fund on that. So if you're a developer for the dApp, and you can provide a interface, kind of like an interface of your application to the different blockchains, so the users residing on the different blockchains, only if that blockchains are supported by CCIP, they can interact with your application without moving their fund. Yeah.
Perfect. Thank you, Frank. And this is what Frank told you to us until now. So imagine this, you have the Cersei blockchain, and you have your smart contract in the Cersei blockchain. Over there, this blockchain, this smart contract is communicating with the router, and then we have the CCIP part that's off-chain, and this is more than one chain. I will show you in the next slide. Communicating with the router in the next blockchain, and then if you have a message, you must have a smart contract to receive this message. If it's only tokens, you can send it directly to the end user as well. And like I told you, imagine that the off-chain part must be decentralized. We have 3 different networks that are part of this to be sure that this cannot be compromised, separated roles over there, and this is how the structure of the CCIP. Also, you can see over there that we have tokens. We have token pools. You can have the option of lock or burn tokens and unlock or mint tokens in the other blockchain. We have more to talk about this as well. So these are the chains that we have with CCIP. Many of these chains are here now. They are sponsored, so you can have both, use them with your project. And would you like to have a CCIP with your own token? This is possible now. Frankie, can you tell how is this?
Yes, that is a very long story. So when the CCIP 1.0 first published, and we supported a list of the tokens. And if you want to move the tokens in that list from the source chain to the destination chain, and that is very easy for you to do. You just send a transaction to the CCIP to say like, I want to burn this token on the source chain, and can you just mint a new token under my address in the destination chain, and the CCIP will help you to do that. But as a CCIP, we need to manually add the token to support the tokens people want to move across the different blockchains. But usually we receive a question from the developers, especially for the individual developer, to say like, I just create a token, and can I just use a CCIP to move my token from the a Polygon to the Arbitrum? How we can do that? So before the Chainlink CCIP 1.5, it's a little bit complicated because you need to deploy your token smart contract as well as a pool smart contract, the token pool. I mean, so you can just log your token and release your token and burn and mint your tokens, but you need to develop by yourself. But with a new version of the Chainlink CCIP, we introduced something called cross-chain tokens and the CCT standard. So this standard offers a token standard to allow the developers to use this token and the token pool as well, based on this token to deploy this two smart contract and then register this token with the Chainlink CCIP. So with this mechanism, you can move any token you want from the source chain to the destination chain. And what's more, you can also set the rate to move your token, like only maximum of the 100 tokens per minute. You can do this with a Chainlink CCIP. And by doing this, actually, we don't require all the developers to use our token standard, but at least you need to have the burn and mint or other functions within your smart contract like ERC20. So there are actually two primary ways to move the tokens based on the CCT. So if you are the deployer of this token and you have the full permission to grant anyone to call the mint and burn functions, you can use the first way to mint and burn. You can, when you want to move the token from the chain A to the chain B, you can first burn this token on the source chain, and then to order the CCIP to mint a new token on the destination chain. But for this one, you need to have the permission to allow the token pool smart contract to call the specific function within the token contract. This is a highest efficiency for the token bridge. But if the token is deployed a long time ago and you are not actually the deployer or the admin of this token contract, you cannot allow someone else to call the function like burn and mint. What you can do? You can use like a lock and mint or lock and unlock. For lock and mint, you only need to create a token pool on the source chain and lock this token. When I say lock, I mean move this token to the token pool smart contract. Then to mint a new wrapped token on the destination blockchain. So there is an original token and there is a wrapped asset on the different blockchains. This is very necessary for the token that has a very long history and you do not have the full permission and you can do the lock and mint. Or if you want to use that in the reverse order in the destination chain, just burn that wrapped asset. You just create it based on the original token on the source chain, and new token can the token can be unlocked on the source chain, and you can get it back from the destination chain. And we also provide the lock and unlock as a third way. So this is actually, the liquidity fragmentation will happen in this mechanism because you always need to maintain a pool of the tokens across the different blockchains. this is necessary for the tokens. You do not have the permission, but the token smart contract is this native token smart contract is deployed across many different blockchains. So they can provide a handle for the developers to move the token from your address to the token pool, and you can have the different token pools on the different blockchains, and you can use the lock and unlock the mechanism to move the tokens across the different blockchains. And yeah, so you can find, actually for this process, you can find the graph and all the instructions in this URL. That is in the official documentation from the Chainlink, and we provide a very, very detailed instructions that how you can do that. So to simply put, what you need to do is that you first need to have your token smart contract, and then you need to add an admin role into your smart contract. And if you do not have that functions within your token smart contract, you have already deployed that and you do not have a function, it's okay. You just need to create an admin for the CCIP as another functions in the token pool, and then register your token and a token pool smart contract with the Chainlink CCIP registry, and then you can use that Chainlink CCIP to move the tokens. You just create it and deploy it across the different blockchains. And yeah.
Is this amazing? And if you try to read our presentation before and the QR code was not working, it's working now. You have the presentation. And by the way, when we talk about CCIP, when we talk about cross-chain, this can take time. And to be sure that you are in the hackathon, you must be fast. So we have the local simulator. You can simulate all of this directly, locally, without a chain, without having no congestion, nothing, and no waiting times. And this will be so better for you to be an efficient hacker. And this is the link of the local simulator for you. And also, we are sharing the presentation later. Good, perfect. And let's move forward. So let's talk a bit more about the data feed and that data stream. And this is the flow that you must understand. Like we have different data sources. So the Dawn, the nodes are getting this. Like being the data providers, they are like doing a volume-based average of some code, for example, and then they are sending this to smart contracts, and your smart contract can interact with them. But we can do this in different ways. But before that, Frank, can you talk about the use case?
Yeah, so for the Chainlink data feed, that is, I think that is the earliest service we provided to the Web3 industry, like 5 years ago, and a lot of the different projects are integrating the Chainlink data feed into their protocol. And if you are a developer to build something like a DeFi, the decentralized finance, there is a very decent chance that you are going to need a Chainlink data feed in your project, because whatever you do, you need to know the price of the asset. User interact with your protocol, or user collateralized their asset in the protocol. So the common use cases for the data feed is like lending and borrowing. So you have a protocol that a user just stake their asset and get some liquidity back. In this scenario, it is very important for you to get the correct price of the asset staked by the user. And the price, the price is pretty important. And if that price is wrong, maybe the other users in your asset pool will lose their money. So that is very important to secure that price data is correct. And except for that, maybe if you want to build something like a mirror asset, or we can call it a synthetic asset. The original idea is that we can allow the users to not only treat the native tokens on the blockchain, but also treat the asset from the real world, like a stock market or fiat or a commodity. And for this one, you can get all the different types of the commodity or other asset as a price from the data feed. Yes, we also provide the price for other commodity. And also for the stablecoin, you need to know the value of the asset staked. And for the option and the future, you know, that is even more important for you to get a price data correctly from the data feed.
Yes, but it is important. Remember that I told you about the data feeds and the data streams. What is the difference, Frank?
Yeah, so for data feed is it's like a push based. So if you want to use a data feed, you don't need to pay for the data feed like every request you need to pay some tokens. You just need to wait like a data feed will push the price data into the smart contract based on two conditions. If the price of the token alternate more than maybe 0.5%, then there going to be a new update. Or if the heartbeat time end like 1 hour or 45 minutes, if that time expires, the new price data will be triggered. So if you or your project is very sensitive to the price, maybe you don't want to wait for a very long time. If that price of the token alternate more than 0.001%, you want to get a new update. Then in this scenario, you need to just manually send a request to the chain link, and the chain link will just catch your request and get whatever you want and feed that back to your smart contract. And that is called the pull base. You need to send a request, and the chain link will get a request and give you a response. And that is called a data stream. Yeah.
Exactly, exactly. So amazing, Frank. Thank you. And I'd like to talk about chain link functions because imagine that probably you must get information that's outside any blockchain. Imagine that you can run a JavaScript code inside your smart contract to call any API, any external API. You can do this using chain link functions. So the goal is this. Even if you have secrets, even if you have parameters, doesn't matter. You can use chain link functions to call external APIs with a JavaScript code inside your smart contract and get the result in a decentralized way and then use inside the blockchain. These are some examples that you can do that with weather, flight delay, greenhouse gas emission, elections, and a lot of things. I suggest you to go to usechainlinkfunctions.com. We have tons of examples for you, the code, the JavaScript code, the APIs. And also, if you'd like to simulate this, the JavaScript code before added in your smart contract, you can use the playground to do that. And we know that we must speed up your development. So we have tools for you. We have the Hard Hat Chainlink plugin, and we have all the services, or most part of the services over there, and to deploy locally as well, and all the support that you need to be faster. Also, we have the Foundry Chainlink Toolkit. I know that some people prefer Foundry. We have for our few. We are covering our few. And Harry, can you tell more about the Chainlink Deco? This is so new for me.
Yes, sure. So we just recently released a thing called the Deco Sandbox. So Deco is a ZK TLS oracle that lets you prove data about the outside world on-chain. So it's not quite a polished product yet. However, we've released a sandbox where you can play around, call some APIs, create some attestations and have them put on chain and proven. So you can actually go into our Deco sandbox and create some of these examples yourself. And as you can see, there are some use cases that we've mentioned there, such as verifying someone's identity, maybe getting their passport or something and proving that on chain without revealing the actual passport. And you can actually go in the Deco playground and create it yourself. And there is a bit of a process to get it on chain because once again, it's not part of our official Chainlink node yet. But if you're interested in this, come chat to us. I'll show you how to do it. It's quite easy, but it's just a manual step basically. And you will be applicable for the non-CCRP prize pool if you do something with the Deco sandbox as part of your project. So very interested to see what kind of things you guys think of if you choose to play around with this.
Okay, thank you, Harry. And this we also have a VRF. So this is the verifiable random function. And Frank, can you explain for me some use cases for VRF? Why I need the VRF?
Yeah, so you know that getting a randomness on the blockchain is always a problem. So before we use a central server to provide a random number to the on-chain smart contract, but you know it is not that reliable, right? And after that, we can just use the transaction hash as a seed for the for the randomness, but if that we only rely on the on-chain data, maybe the transaction hash can be computed by some big miners. So for the Chainlink VRF, we provide the randomness with a proof, and you can use a proof to prove that the randomness provided by Chainlink VRF is just secure and just predefined functions. So we all agreed. So for the Chainlink VRF, if you are building the NFT smart contract like a gaming project, you want the different developer, or I'm sorry, the users to mint your NFT randomly, or you want to pick some people from the whitelist randomly, and you need a randomness for this kind of scenarios. So, for example, if the feature of this NFT is rare, and the feature for that one is super rare, you need to have a mechanism to decide which is better and which is not that good. So for the NFT creation, distribution, or raffling, or just fair selecting some people from the whitelist, you can use the Chainlink VRF to do that. And we also have an article to list all the 35 use cases, and the URL is on the bottom of this slide.
Exactly. This is important to you. I know that some of you are still thinking what I can build in this hackathon. You can have these use cases, and that can help you as well. And this is talking about automation. So imagine that you would like to have some conditions updated inside your smart contract. Do you know that your smart contract cannot call itself? So I must have some external way to do that. Okay, I can have like a bot in a Google, in a cloud service, but it's better if I have this in a decentralized way. And this is Chainlink automation. So you can have 3 kinds of triggers. One, by time. I'd like to call my function every day, every hour. I can do that. Or you'd like to call your function every time some token is sent, because the function is, the automation is monitoring the event transfer. You can do that. Or you'd like to call something or to do something inside your smart contract when your balance in that token is low, is almost zero, or any kind of condition. You can choose your condition and run an automation. Check upkeep is the condition. The update upkeep is what you'd like to do with that. And these are some use cases for you. I'm not covering all of them now. If you'd like to know more demonstrations and more resources related to all of these, all of the Chainlink services, this is the way. We have the demos and also the resources over there. And to finish, let's talk about the judges and criteria. So when you are looking your project, we are looking for how you are using blockchain, how you are using Chainlink, and if your project is something totally different, that's the wow factor. And we have more than one person judging you over there. And how to pitch your project to Chainlink. Maybe this is not only for Chainlink, okay? But this can be useful for you. So first, show us the code. We would like to know, are you really using Chainlink? Don't come with presentation if I cannot see your smart contract. First, I must see your smart contract. Where is Chainlink? Then, if you pass this phase, we'd like to see your presentation. But it's better if you use your application, if you really demonstrate something, not only slides. Don't spend too much time showing slides. Go to your application. You build something, use that time to show what you built first. And I think the first part of Chainlink is only for us, but this part is useful for you from the main judge as well, okay? Less time on slides, more time what you build. Okay? And by the way, sometimes in the last day, we have some congestion in the network, in the Wi-Fi. Be ready, have some transactions done like 1 hour before, and the night before, to be sure that you have something to prove your work. Okay? And this is the presentation again. If you could not read before, you can read now. And it is working now. I'm sure of that. Yes, I think we are, I have one more person reading over there. Yes, almost done. Yes, all good. If you need more help, remember that we have our booth. You can go over there. If like it's like probably 5 a.m. we are not there, but we have people on Discord in United States that will be in other time zone in their day, and they are monitoring the Discord as well. So we are ready to help you. And this is, thank you so much.
Thank you so much, and good luck to everyone. Enjoy the hackathon. Thank you so much.
Hi everyone, welcome to the Chronicle workshop. We'll be talking about powering the apps with data from Oracle. A few words about myself. My name is Bianca Buza. I'm lead DevRel at Chronicle. You can find my social media links. I'm always more than happy to chat, answer any questions. I'm also going to be at the Chronicle booth. You can find it on the left side here. We'll be here until Sunday answering questions, helping you work on your projects. And yeah, please come by. We're happy to chat and help you find teammates and ideas to work on. In terms of agenda, we're going to look at oracles, what are oracles, then what we prepared at Chronicle for ETHGlobal Bangkok. Then we're going to look at why Chronicle, because you might have seen there are multiple oracles at this hackathon, so we want to show you what differentiates us. And then we're going to have a brief hands-on of building with Chronicle. So first of all, what are Web3 oracles? I like to explain oracles by using this very simple yet powerful analogy, I would say. So if you think about your mobile phone is powerful because it allows you to interact with all these different applications. But in order to do that, there is an exchange of data between these applications and your phone. Now, when you put your phone on play mode, all of a sudden this transfer of data doesn't happen anymore. So very soon your phone becomes pretty much useless. You can't do much with a phone on airplane mode. Similarly to that, oracles need data. If you think about the blockchain is like a big sandbox that doesn't know anything about the outside world. However, in order to build useful applications on the blockchain, you need data. So using oracles, which are the middleware, we take data and we put it on chain for smart contracts, and from there, different applications can read from those smart contracts and use that data for various use cases. We're going to see in a bit what use cases you can build with Chronicle oracles. Now, a few words about Chronicle. Chronicle has been around since 2017. An interesting fact, actually, is the very first oracle on Ethereum. Last year, it spun out of MakerDAO under the brand of Chronicle, and now the protocol, it's open for everyone, and it powers other dApps as well. In terms of TVS, or total value secure, there are around 9 billion of assets. So not only that it has been running for so many years, but also it has been securing a great deal of assets. Now, what is special about our oracles is our Chronicle Scribe. This is an extremely gas-efficient oracle using aggregated Schnorr signatures. Schnorr signatures have been around for a while, since the 1990s. They even are used in Bitcoin. However, this is the first time when we use Schnorr signatures in the context of Web3 oracles. Now we're going to see what are the specific characteristics that set apart Chronicle Scribe oracles. So we're going to talk about the decentralization, verifiability, and scalability. The first one is decentralization. So Chronicle is powered by a decentralized network of validators. You can see here some of the most reputable protocols in the Web3 space, like MakerDAO, EtherScan, DeFi Saver, ETHGlobal, and many others. And the idea here, it's simple. Basically, these validators are staking their own reputation when they're putting and signing data to get on-chain. The next property is verifiability, and I want to run here a short demo to show you how you can trace end-to-end our oracle. So here I'm on the Chronicle dashboard at chroniclelabs.org/dashboard, and you can see here all the oracles. I can go ahead and select one of the oracles. Let's say the ETHUSD one, it's a popular one, and I can see all the validators that have taken part. If I select one of the validators, let's say, I don't know, Gnosis, I can see the different data sources that have been used by that validators. As you can see, it's a combination of on-chain and off-chain data sources. I can even do, take it one step further, and I can verify in the browser the signature for this validator. And basically, I can prove that even the tiniest change will result into making the signature invalid. So here is like the unmodified version, and if I go ahead and do even the slightest change and delete a 0, it's gonna say that the signature is not valid anymore. Similarly, I can verify the Schnorr signature. This is actually the data that gets pushed on chain. So same concept here. So this is about the end-to-end verifiability part. Let's go back to the presentation. Scalability. So using optimistic Schnorr signatures, we are able to reduce the gas fees over 60% on layer 1 and over 68% on layer 2s. And why is this important? Not only that you will have a lower bill in terms of gas costs, but also what is very interesting is that it allows you to decouple the gas costs from the number of validators. What doesn't mean is that you can add as many validators as you want without inflating your gas costs. So now you can achieve actual decentralization because you have more validators, which also results into better security. Now, I'm sure you're here for building this weekend, so let's have a look at the different bounties. Chronicle is offering this weekend 10K in bounties for ETHGlobal Bangkok. If you want to scan the QR code, please go ahead. It's going to take you to a page with all the resources for the hackathon and all the important links. So please make sure to scan that. one track for the best integration of Chronicle oracles. We're keeping it quite open. As you can see, you can integrate any of our oracles from the dashboard on any of the 10 chains where we're live for your favorite use case. Some example here, these are only to get you inspired, but please go ahead and build whatever you're passionate about. Some examples are a game with dynamic prices, a reputation system, an analytics dashboard, an AI optimization for DAO treasury management, etc. We also have a prize pool where any valid submission gets a share of the prize pool. So if you're submitting something this weekend for Chronicle, you at least get qualified for the prize pool if you don't get one of the prizes in the integration track. Okay, looks like everyone scanned the QR code. Next, what sort of data can I use for the Chronicle track at ETHGlobal Bangkok? As mentioned earlier, anything from our dashboard, you have there the link from our dashboard, any sort of Oracle integration is valid. One of the requirements, though, is to make a state change. So Chronicle is also blockchain agnostic. You can see here the 10 chains where it's currently live. This number continuously increases over time. So this weekend, you're free to use any of these chains. Some of these chains are also offering bounties, so you might want to look into one of those. Something to keep in mind, please always make sure to check the correct addresses for that chain, because both the oracles and the self-kisser contract that we're going to talk in a bit for whitelisting have different addresses for different chains, so always make sure to have the right address. Now, the fun part, how do I use a Chronicle oracle? I have that QR code over there that I invite you to scan. It's going to take you to a guide that shows you how to integrate Chronicle oracles. But before of that, I want to explain you the overall concept. So Chronicle oracles are read protected by a whitelist. What does it mean? It means that in order to read from the oracles, you need to be whitelisted. Now, the good part is that on testnet networks, you can whitelist yourself. We have a self-kisser smart contract, and using that, you can do the whitelisting yourself. On mainnet, you need to come and talk to us, but that's a story for another day. We're here at the hackathon using the testnet, so that should be fine. Here I have the process of what you need to keep in mind when you're reading from Chronicle Oracle. The first step is you select the chain that you want. I showed you the 10 chains where it's available. You make sure to get the address of one of the oracles you want to use. And then you get for the same chain that you selected, you find the address of the self-kisser. Now that you have the two addresses, the self-kisser and the oracle, you can use the self-kisser to whitelist the address that you're going to use to read from the oracle. Something to keep in mind here, the whitelisting process is a right operation, so make sure to have funds to cover for the gas costs. Okay, time for a brief demonstration. So here, if you remember the QR code that you scanned earlier, maybe I go for one more second to it. This QR code here. We're gonna see live what's happening, an example. Okay, so basically here I have a, let me see if I'm on the right one. I have the contract for the Oracle reader. It's quite a simple contract. First, I define an instance Chronicle. of type iChronicle interface, and I pointed to this address. This address is the address of ETHUSD on Sepolia network. Then similarly, I define an instance self-keysr of type iSelfKeysr interface, and I pointed to this address. This address corresponds, as you can see here in the comments, to the self-keysr on Sepolia as well. So always make sure to match the networks. And then in the constructor, I do the self-keys, the whitelisting part, where I whitelist the address for that oracle. Something to note here, if you're using multiple oracles, make sure to whitelist the address for every single oracle. So for example, if you have like ETHUSD and Bitcoin USD, let's say, you need to whitelist yourself for each of these feeds. Then we have like the read function, which basically returns the value and the age. The value represents the value returned by the oracle, and the age represents the Unix timestamp since the latest update of the oracle. So you can see basically how old is the value that you got from the oracle. And here, next I just have like from the interfaces, the functions that are relevant. You can see here, I think I have, where do I have? I had the interface. I wanted to, here. Here is the iChronicle interface. As you can see, it's quite light, and in most of the cases, you will want to use one of these two functions, either the read function that returns only the value of the oracle, or the read with age function. This one returns the value of the oracle and also when was the last time the oracle was updated. Okay, so we have our instance. We can compile our oracle and deploy it. I'm making sure to select the oracle and not the interface. And let's see if the internet is in our favor today. Okay, so we have here an instance of the contract. Here we're going to have the address of the oracle. We're going to have the read function. You can see here the value return. Looks quite a big number. I know we're in a bull market, but we're not there yet. So what is happening here? Chronicle oracles operate with 18 decimal places. So every time you get the return value from the oracle, make sure to keep that in mind, that there are 18 decimal places. And the other is the age. As I mentioned, this is like the Unix timestamp. If you go to a converter, you're gonna get the date. All right. Let's go back to the presentation. So we talked about these. We also have Scaffold Oracle Reader. For those of you familiar with Biddleguild, Austin Griffith, and the Scaffold ETH, we also have such a repo to allow you like to build very fast during the hackathon and only focus on the parts of the project that differentiate it. So this is a great resource. And let me show you briefly the page for the hackathon, because I think this is the most important page. You're going to have here the contracts. You can see the contracts for our oracles either on the dashboard. If you go here, oh, not here. The dashboard, sorry, here. Make sure to toggle the dev mode for testnet. You can find here all the oracles. Or we also have like in our documentation, but I recommend getting the addresses directly from the dashboard. Then here it's a note about the whitelisting process that I just explained. You have an overview of the bounties and the different resources. We have the Scaffold Oracle Reader built on Scaffold ETH2. There is also an example here about creating a token vendor, so you can get inspired by that. And also there is an example here about integrating Cartesi rollups with Chronicle Oracle built by a community member. Yeah, and you also have like some RPCs and some common pitfalls to keep in mind. And as mentioned at the beginning, make sure to come by the booth, ask us any questions. And yeah, if you need help iterating, finding a team, or just finding an idea, more than happy to support with that. Do you have any questions? Yes? One second. Can we get a second mic for the questions? There is a mic here.
Yeah, so I got one question was regarding to read like the Oracle, you don't pay fees. It's only like when you request into the smart contract, like to get the price. I mean, maybe my question was like, I mean, if for instance I have a front end and I want to kind of read, you know, like the USD value of some ETHs, we're using Chronicle, I'm not going to pay fees for that, right?
Yes, so you can read, you don't need to have like anything to read from the Oracle. You just do the whitelisting process and you read from the Oracles, at least on testnet. On mainnet, yes, usually like you need to come talk to us, and like if you're a big protocol, there is like there are some steps to go for the integration. But from the point of view of the user, yeah, you can just go read from the Oracle and you're good to go. You just like for the whitelisting itself, you need to make sure that's just like a right operation. You need to whitelist yourself, and you need to have like a bit of gas to do the whitelisting.
Okay,
but
so
that's very low.
Okay, so my understanding is like it will be the protocol that's going to pay for the kind of Oracle mechanisms, right? Not the users.
Yes, it's on the protocols. Yes.
Okay. Yeah, I also got a question regarding like more about the slashing mechanisms, because currently we have like a bunch of oracles that can provide price, especially off-chain, and I was wondering like how how the slashing works, because if one provider just give a wrong price, how it is managed?
Yes, that's a great question. You mean for the validators, right?
Yeah,
like if one validator puts like a bad price. Indeed, we have that process where basically anyone can challenge data that is not valid. So if the signature is not valid, like anyone can do that, and they even get like a small bounty. Like if you manage to find someone who acted maliciously, or just like they did a mistake, if you find bad data, basically you're gonna get a reward. The validator gets removed, and the data, of course, doesn't get included. So besides like the mechanism of having reputable protocols, we also have these extra guardrails. Like not only that they don't have the incentives because their reputation is at stake, but also we have like actually implemented this in the code, and this happens like automatically triggered by smart contracts.
And also like, I mean, do you do like the average of 10 different providers? I'm just thinking about maybe one scenario where maybe one provider is going to have an issue internally and get maybe a price of 0, you know? And so I was wondering like, do you do maybe an average or something like that, or it's...
So in terms of data aggregation, average, when it comes to oracles, average is not really good, because if you have outliers, those are gonna affect negatively. A better way to do it, and what we also use, are medians. In our case is median of medians. So we remove the outliers and then we do the median.
Okay, got it. Thank you.
No worries. Any more questions?
Why do we have to whitelist the address?
That's basically because like on mainnet, that's our business model if you want. on mainnet, we do that, and there is like an integration fee. But on testnet, we want to replicate as much as possible the process for mainnet, but it's just like for free on testnet. Yeah, it's just part of the business model. And also some sort of security for the oracles, because otherwise, like you can get like a lot of people that can potentially exploit.
So loud in here.
Any more questions? Okay, looks that there's a wrap. See you at the Chronicle booth, and best of luck with your builds. Don't forget, if you're submitting for the Chronicle track, come. We would love to see you in person present, if it's possible, of course. If not, also like a short video works.
There's an open if you need some water.
Should be fine, should be fine.
Yeah, because this is your mic? Mic. Go on, then you can see. And then that one, yeah. And then we wait for a bit because we start in like 4 minutes. Okay, cool. Yeah, this will be your mic, and here.
I was presented this thought by some people that opened this beforehand. So it's for your back so that you don't. Yeah. I know because a guy came, opened this and said, you know what I think about this. Look at this. That guy, exactly. That guy in the blue shirt. You can thank him. Okay, so let's start. So Flare, what is Flare? Flare is blockchain for data. So Flare is a EVM layer 1 blockchain, totally independent. But apart from other blockchains, we allow you to get access to decentralized data in a safe and secure manner, and also very cheap and very quickly. So it's easy to use and it's safe to use. So if you're on blockchain, that's a data source you should consider. And let's just quickly go through things you should be focusing on this hackathon. So Flare is an EVM chain. What does that mean? That means that everything you already know about EVM chains, Solidity, Hardhat, Foundry, anything you want to use, all the toolings are already available. And what we're challenging you to do, so what we want you to do is to build on this EVM chain with external data. We're offering 10,000K in rewards to effectively do two different things, and they are the most important. So one is to utilize the FDC, the Flare Data Connector, which allows you to connect external data to blockchain. So it allows you to bridge something that you can only see in external world, use it on chain, and be sure that this is secure and secured by the whole stake in the ecosystem. So it's not a multi-sig, it's not a single party moving data from off-chain to on-chain, but it's something that the chain is doing itself, and the chain is making sure that it's secure. And the second thing you can use is the FTSO, which is shorthand for Flare Time Series Oracle, which allows you to have real-time pricing data directly on-chain. What does that mean? And we'll show this in the workshop. It allows you to get the price of a specific asset in real time, every block on-chain. And again, as with the FDC, as we told, that's available on Flare, you know that this is secure by the whole network itself. So you can always make sure that the data you're getting is correct and nobody can hamper it in the meantime. So just a few words how that works, because it's important to know exactly why you need this data and how you get it. So the FTSO is a decentralized price oracle. You have decentralized price information that is operated by the staked network of validators. So we have this directly enshrined on-chain, and this allows us to have the flexibility, the speed, and also the security layers. And the prices are updated every block, which means that you get a new price every second or 2 seconds, depending on the block time. So we use a pretty fast blockchain, so you want to get prices fast, and also our blockchain makes sure that the gas fees are low, and we're not adding any additional fees on top of it. And then the FDC allows you to get deterministic off-chain data, so anything you can see in external world can be bridged by FDC to chain, And then since you're on EVM chain, the only limitation you can have is what you can think of. So a few specific examples. So we support all EVM chains. Currently, we are deployed on, we support Ethereum, Ethereum and testnets of Ethereum, and some Cosmos chains, but you can come to our booth and ask us and we'll quickly add a new chain just so that you can see and you can play around with it. So if a chain is EVM compatible, we can quickly add it specifically for this hackathon so you can try and see what else you can get from that chains. And from EVM chains, you get the most important thing, which is events. So you can attest to specific event happening on an EVM chain, and then you can use this on Flare to do something else. So you can attest to a Uniswap happening, you can attest to a transfer happening, you can attest to an NFT burning, and then upon this NFT burning, you do something else on Flare and have the connectivity. We also connect to some so-called non-smart chains, BTC, Dogecoin, and XRP Ledger, and we also give you information about them. So what this means? Well, this means that you can get information about the Bitcoin transaction, move it to Flare, and once this is on a smart contract network, you can do anything you want with it. So this allows you to collect payments in Bitcoin, this allows you to collect payments in XRPL, and it also allows you to then do some work on top of it. And combining this with FTSO, you can always know how much you have been paid in dollar value, because you always know how much the underlying was worth at that specific point. And apart from this, we also connect to custom Web2 sources, which is one of the additional challenges in this hackathon, which is invent your own Web2 data source, invent your own specific attestation type, connect to a new API we haven't thought of, bridge data to Flare, and then on Flare, do something amazing with it. So use the data you've been gathering, use it, get it on chain, and then do something that is only possible on blockchain because of those trust assumptions. And then we also have some additional things. So we also provide you a free and readily available random number directly on chain as a byproduct of all other protocols. Well, what can you do with a random number on chain? Well, think gambling, think something else, think pretty much any luck you would like to involve, but you can also use it in some other things. For example, you can sample some stuff. You can add a challenge for somebody to prove something else, and this is again available on-chain and secure. And we've been connected by a layer 0 to all the connected networks through layer 0. So this means that any data that you have on chain or anything that you do on Flare can easily be relayed by a layer 0 and also by Stargate to any other network. This means that your applications can now become data very rich while also incorporating other networks, making your application truly multi-chain, and knowing that the data that is coming to your application and the data that is guiding your application is secure and makes sense. Okay, so and just a quick talk through this. So EVM compatible Oracle network, what you get all the nice things without any limitations. Low transaction fees, access to all the tooling. You get ERC20 tokens, NFTs, all these things for free. You can use Open Zeppelin libraries. We provide all these directly on chain. So there is no change here. The only thing you need to do is you need to change to a new RPC, and you have a better network, faster network, cheaper network, and better data. Okay, and let's see the thing that we're kind of focusing on this hackathon. So as I said before, we offer 3 different protocols. One is the FTSO for pricing data, one is the random number, and the third one is the FDC. So we're going to take a look at how to use FDC and FTSO in this workshop. And one of the things we're going to check is a custom JSON-based web API. So what this allows you, it allows you to build your own post-processor. So pretty much it allows you to take arbitrary code, put it on a verifier server, let the verifier server run this arbitrary code, which is then run by the whole set of attestation providers on Flare, which is the same as the validator set. So we bundle those 2 roles together, and then you can attest to this computation on Flare. So what this allows you to, you can create, for example, any JSON API you can find in the wild. What you do, you create a source that is able to read this API. You create a post-processing code that is able to post-process this code to something you can then use. And then this gets attested to in a decentralized manner to chain. And once you're on chain, you can directly use it for whatever you need to do. And we're going to see how you can use this in a weather example when we're going to take an open weather API. We're going to check the data. We're going to post-process it to something nicer so that you can use it on chain and in Solidity. And then we're going to see a simple smart contract that just verifies that this data is correct, and then uses this weather for whatever you need to do. Here the sky and your imagination is the limit. Okay, so here's the workshop. You can scan this if you want to work with me. Otherwise, this is all on the Notion page. And if you run into any troubles, we're just on the other side of this big space, just on the left side of the main stage. You can find us there, those boys and girls in these pinky branded uniforms, and you can ask us a question. Okay, so let's see how that works. So the first thing we're going to check is an example on how to gather the FTSO data, how you can easily get prices on Flare. Okay, let's enlarge this. Can you see this? Can you see this now? Okay, so this is the FTSO contract. So the FTSO contract allows you to gather data from chain. So we made it as easy as possible by using our periphery contract libraries, which allow you to connect directly to the necessary contract. So, and here's a simple smart contract. I'm not going to write it. I'm just going to guide you through it. And the only thing you need to do is you need to get the FTSO. In our case, we're going to be using the test FTSO, which abstracts even more things away. But on a real network, the only change is that you have to make a call a bit differently, but it's a minor change. And we're going to use the feed ID converter that is going to be useful in a later stage when I'll show you how you can get a bunch of these things in the same call. And the main thing you have to do to get the price is pretty much call the FTSO v2, get feed ID, and provide the feed ID you want to use. So we currently support 50 different feeds directly on chain that are refreshed every second. And that's all you have to do. So get feed ID for feed flare/USD. Okay, and you can see this is encoded into bytes 21. This might seem a bit daunting, but in reality, this is just hex encoded FLR/USD. So you can easily decode this back and present it to a user in a nice way. And in another perspective, so you can get a bit more generalized way when you allow user to provide you a feed ID. But if you want to be really, really nice to user, the only thing you need to do is you can get a feed name from the user, and you just convert it using our library for conversion. And this conversion, I can show you that this, okay, it's an interface, but this conversion is just hex encoding, which is just ABI encoding two separate bytes, and this is just the conversion. Okay, so that's how you get the prices, and then in the same contract, so this is also available on the Notion page, so you can check the contract. There's a starter pack that contains all the necessary information. And then there are just a few nice auxiliary methods which you can use to check which feeds are available, how you can query them, and so on. Okay, and of course, I have to do this, but no demo is as good as a live demo. And to deploy this, since we're an EVM chain, the only thing you need to do, you just need to create a new contract and deploy it. And also in this Hardhat Hardhat starter pack, will automatically verify this for you on a Flare Explorer, and so you can easily check this and play around with this. Okay, so the contract has been deployed, and let us just wait for the verification status, and let's open this. Okay, that's the deployed contract, and as I said before, we're an EVM chain, so all the tooling you're familiar with is already available. You don't have to change anything. Okay, so you have a contract. What you need to do, you can read the price, and let's see which feeds are available by name. And you have, okay, here's a bunch of feeds that are available, and I'm just going to copy that one and check it here. And I just read it. So this is a simple example. If this were your smart contract or a dApp, you would just call an RPC with that. So we get a price for Bitcoin, and we also get some additional information. So how many decimals is it in? Because you don't want to use floating numbers in Solidity, we already encode and decode this into nice uint representations. And we also give you a timestamp when this was last updated. So you can always know how good your prices are and how stale they might be. Okay, so this is the FTSO. Easy to use, directly on-chain methods that you can read. Yeah. Yeah, the timestamp is just the block timestamp when this was latest updated. So we wanted to make this as simple as possible. So you can compare this to Blockstamp and you're fine. Okay, so this is FTSO. Using the random number would be the same. You pretty much just take a different interface that's available in a long-term support interfaces and query the random number. Now the fun part that you can do is these so-called arbitrary data types. So what arbitrary data types allow you is to do the following. So you can define, so we're going to do 3 things in a succession, but we're going to do them quickly because this is a workshop. If you want to know this into detail, just come to the booth and we'll show you a bit longer tutorial how to do this. So what JSON API allows you is to set 3 things. So you can say, I want you to go to this URL. I want you to post-process this URL with this JQ. And then I want you to encode this JQ post-process JSON into a Solidity data type. And what that allows you is you can say, okay, we're going to go to the weather API. We're going to get some information about the weather in Bangkok. We're going to post-process this with JQ to a nicer representation that contains only the things we want to know. And once we have this, I'm going to provide you with an ABI definition for a Solidity type so you can encode this into exactly the structure I'm going to use later in my contract. And what this allows you to take an arbitrary API, say how you want to post-process it, and then use it in your contract however you want to use it. Okay, so how does this look like? We have a specific server that you can run locally, and you can say the following. We're going to go through this in a few steps, so just so that you know how all this looks. Okay, so this now fails, but the important thing is this. So we first make a request to a weather API, and we get back a JSON like this. So, and what you're providing to the verifier server is this URL. So please check this for me. We're going to copy this to JQ Playground, apply the JQ transformation, and we get back this. Okay, so this is the, so we start with an arbitrary API, we set a JQ response, and we end up with this. So I've parsed out just the specific fields I want to use. I don't need clouds, I don't need visibility, but I do need latitude and longitude, temperature, and I immediately multiplied this by 1,000,000 so that I again lose the decimals. I don't want to use the decimals. I want to be in Solidity nice types. Okay, and if you can see, it's a bit hot in Bangkok. Can you say why? Why is it so hot? Huh? Yeah, near the equator, but it's still a bit too hot. Why? Because this thing is returning the temperature in kelvins. So, and we don't want to do this in Solidity. So what you can do, you can just change your post-processing and change this to Celsius, apply the post-processing again, and say, okay, so please return this in Celsius. And the only thing you need to do, you need to provide this to the verifier server. So you have the input, you have the post-processing, and then you just need the encoding type. Okay, and let's see how this really looks in this in the code. Okay, so what you do, you first ask an off-chain server, and you say the following. Okay, request body. I want you to get to this URL. I want you to post-process this by this specific JQ, and then at the end encode this to this specific structure. And this structure is the same as the one you then use in your Solidity code. You see the idea? And what you have to do off-chain is the following. So we've mocked quite a few of the things for hackathon, so we don't have to go through all the consensus algorithms. We just always make sure that your data is correct. And then what you do on the off-chain side, you just deploy a contract that uses this API instance, and then add this full response. So you add this full response from a server, you add whatever the verifier server gave you, and you put it to a contract. And when you are in a contract, the only thing you need to do is the following. You need to check that this is indeed correct. So you need to check against the Merkle root of what the verifiers have come to, that this data point that the verifier is providing you is indeed correct, because otherwise anyone could give you the data on a smart contract. So this is the security part. And after that, the only thing you need to do is decode the response. Why do you have to decode it? Why can't you use a custom data type beforehand? Because you want to keep the message payload as general as possible. So if you change the JQ and get some new data, you will now have to decode it to a new structure. And that's why at the end it's up to you, so you can change your JQ in a very specific new data that can compare stuff, that can compute stuff, that can run a Python script practically to do something, and then it's just up to you to properly decode this. And once you have this decoded as a solidity struct, it's up to you to do something. So here I just push it to a set of, to a list of weathers, but I could easily do if, I don't know, if, let's say, weather dot temperature is greater than, let's say, 20 degrees. Remove the last one. Yeah, okay. So the easiest thing you could do here is you can do some prediction market. You can do some insurance on top of it. It's pretty much you can get any data you want on chain, and once it's on chain, it's up to you to do whatever you want to do. Okay, so that's it. Yeah. It's
Guys can continue to the booth.
yeah. Okay, we can continue. If you have any questions, come to the booth.
Yeah,
And
please.
we'll show you that.
Okay, thank you. Can you hold that, please?
Hello, test, test. Is it displaying? Okay. Hi everyone, I am Sophia. Also, excuse the noise. I feel like I'm at a concert. This is really funny. But essentially, I'll be talking about Cello, particularly how to build on Cello and why this is a great opportunity to build apps for everyday problems for everyday users. And then a little intro about me. I am currently the DevRel engineer lead at Cello. And if you have any questions, feel free to find me at the Cello booth afterwards or add me on Twitter. Before I go into everything, wanted to do a little brief of what is Cello. Has anyone here heard of Cello before? Like a quick show of hands? Awesome. Okay, I think that's most of you. But just as a little recap, Cello is an emerging Ethereum layer 2 and mobile-first blockchain network that is built for the real world and designed for fast, low-cost payments worldwide. So what exactly do we mean when we say Cello is built for the real world? Well, is anyone familiar with this campaign, the Crypto is Useless campaign? Have anyone heard when maybe you're telling your parents or friends like that you work in crypto and they respond, well, crypto is useless. Is that like a saying that you've heard? Well, for many don't understand the real world applications that crypto technology can have. And it's important that we continue to build for users that need crypto. So to this argument, crypto is useless, we'd argue that crypto is not useless if you need it. Wait, how do I, let's see. I don't know how to play video. Sorry, 1 second. I'm trying to get my video to show. Okay. Wait, sorry. I'm not sure. I'm not sure what happened.
Me neither.
I'm gonna stay like that. Okay, let me just do Google.
Yeah, I think it's on the other screen, right?
Oh, got it. Yep.
Yeah, like this.
Yeah, that's fine. Okay, sorry about that. The video wasn't working on this, but essentially for Cello, our apps are particularly designed centered around solving a real world problem. So as we see, we have MiniPay, and it's arguing that crypto is not useless. Whether you've lived with hyperinflation, or you've run a small business, or whether you need certain microloans. So these are some of the applications within the Cello ecosystem, and we're really targeted on our end users. So Cello is specifically designed to enable real-world use cases on Ethereum. So we're a layer 1 EVM compatible blockchain, and we're actually in the process right now of transitioning to an Ethereum layer 2. And we're optimized for mobile first. So we have certain features such as mapping phone numbers to wallet addresses, or paying for gas fees with local stablecoins instead of needing a native currency. So you can check out all the other Cello-specific features that enable app developers to build things and real-world use cases on top of Ethereum. So a few of the bounties that you can expect and apply for that I want to talk about more in-depthly today during this workshop is building an app built for mobile. And so we are offering 6,000 CUSD for this app, and I'll go into a little bit about what you can expect from this bounty. And then the second bounty that we have is the best open source tool built on our Cello L2 testnet. So like I mentioned before, Cello recently just deployed our L2 testnet on Alpha Juarez, so you can be one of the first builders to actually begin deploying and using this tool. So why mobile first? Well, 3 out of 4 people in the world own mobile phones. And right now, dApp development is optimized for desktop. So if we're only building applications where users can interact with the blockchain via a computer, we're really missing out on opportunities to be building for the global majority and building for users who can access the blockchain via their mobile phones. It's really important that us all as builders, as Ethereum builders, us all who are passionate about bringing real-world use cases of Ethereum globally to billions of users around the world, it's important that we ensure that we're providing value to everyday users where they already are. And one of the areas where users already are is on MiniPay. So is anyone here familiar with the Opera browser? If you can see that little circle. So it's one of the most popular browsers in Africa. They actually offer a little bit of free data each month. So it's one of the most popular browsers in the continent. And a little video about MiniPay. It's a stablecoin wallet built on the Cello blockchain that's natively integrated into the Opera browser. So if you open up the browser on Opera, you'll see a little MiniPay button where you can interact with the blockchain, use stable coins, send dollars to phone numbers, and you can register an account with a very Web 2-like experience. And it also comes with a built-in dApp discovery page. So not only is it a stablecoin wallet, it's also a distribution channel to dApps and regional specific dApps. Right now, MiniPay, since launching, has over 4 million active users and holders of this wallet. So when you're building apps for MiniPay, you are really building for all of these users as well. A few of the features that make this stablecoin wallet unique is that you can map phone numbers to wallet addresses. So you can pay phone numbers, pay people in your contact list, and the end user doesn't really realize they're using crypto. It's also super fast and low cost, so less than a tenth of a cent and 1 second block finality. And we have a dApp discovery page with regional specific apps. So since you're signing up with your phone number, if you open up the dApp discovery page in Kenya, maybe you have an M-Pesa off-ramp, but that will look different from if you open up the dApp discovery page in Brazil. So this allows app builders to build hyper-specific apps for their countries and their regions. And it's also designed for non-crypto native users. So right now, if you're trying to build an app for a non-crypto native user, how will they find out about your application? That's very difficult. With MiniPay, they already are active on this wallet, and they can easily interact with your app straight from the Opera Mini browser. So a little bit of why I encourage all of you all here and what the opportunities are for building on MiniPay is this is truly one of the best distribution channels, I would argue, in all of Web3. You can tap into Opera's large user base, which has about 100 million users. There's integrated dApp discovery, so users can interact with your app straight from the MiniPay wallet. They don't have to re-log in like a MetaMask wallet, pay for gas fees, and you get opportunity to build and for everyday users, particularly users in Africa, but with the MiniPay standalone, this is really extending to a bunch of other regions as well. So how to build on MiniPay? How can you get started? Well, we at Cello DevRel built out a Cello Composer, which is essentially a quick start to easily create dApps optimized for MiniPay. And I'll show you a little bit of how that works. Essentially, there's a CLI that you can use in your terminal to install the MiniPay template. There's some pre-written smart contracts that are already there, and you can also access ready-made front ends to interact with the contracts. And it's also all built on a responsive web app that's optimized for MiniPay wallet testing. So a little bit of how this will work, and all of this, if you want to follow along, is in docs.cello.org. You can get exact step-by-steps, or you can check out the workshop videos where I have an exact template more in depth. But essentially, this is what the app will look like after you install the template. It's like a hard hat and a React framework all there, and then you'll have a link that you can use and actually paste that link right into the MiniPay site tester. So for anyone who has an Android, unfortunately, it's not active on iOS or Apple quite yet. You can download the test flight, and iOS will be coming soon. But right now, you have to test out the app within MiniPay. If you're applying for the bounty, and you don't have an Android, it's not a strict requirement. This is just if you want to check it out. So you can click on the MiniPay and open up the MiniPay wallet. I'll show you a bit of what this will look like. This is how the MiniPay wallet looks like. As you can see, there's a big dApp discovery feed right here. And then you can open up the site tester where you can paste in, load in a website. So this is why we want people to build responsive web apps. And once you have that link, you can paste it into load it inside the site tester and test out different things with this app. So here I'm doing some examples of how you can begin testing out some of the key features that it comes with right away. If you are building on MiniPay and you want a bit of inspiration for apps, ideas, and use cases, we wrote out a few, such as payments on and off ramps, donations, X to earn, gift cards, coupons, merchants, micro work, reward-based games. These are just a few to get you started. Obviously, these are not strict requirements. But I did want to use this workshop and this session to offer a few useful tips for you all. So if you are building for MiniPay, it's really important that you begin with the first thing as focused on your end user. Identify the specific person that you're building for, identify a real problem that they're facing, and design around there. So even think small. You don't need to build for every single person. Think about maybe your where you're from, a regional specific use case to you, and that's the type of products that do really, really well on MiniPay. The other thing is keep it simple. Remember that a lot of the users who are interacting with apps on MiniPay have never interacted with crypto before, and they might not even realize that MiniPay is a stablecoin crypto wallet. They just see, oh, it's USDT, it's stablecoins, or it's a currency back to the US dollar. They don't really get that it's crypto, and they might not get it's crypto. So keep it super, super simple. And then the last thing is make it useful. So a reminder to address a local practical challenge, because again, those are the types of apps that people use. The second bounty that we have available is the best open source tool built on Cell 2, which is our L2 testnet, or Alpha Horace L2 is the technical name for our L2 testnet, and we are giving out $4,000 in prizes. So here's a little graph. We are transitioning from an EVM compatible layer 1 to Ethereum layer 2 on the OP stack and part of the Optimism superchain. So we're doing this one for better alignment with the Ethereum ecosystem and more interoperability. So now instead of being a siloed L1, maybe on a siloed island, we can actually interact and have more interoperability with superchain L2s and other L2s in general. And there's opportunity for native bridging. So this really opens up the landscape. And this is a new chapter for Celo that has never really existed before. And again, you can all be the first to experiment on what this means. We're looking for tools and infrastructure that enhance the functionality of the Celo L2 ecosystem. Some use cases and ideas, again, this is just to get you started, is developer tooling, Celo Composer improvements, like I showed before, wallet integrations. Maybe you can integrate fee abstraction or a social connect into different types of wallets. Superchain interoperability. If you are building on another superchain and oracles, try to figure out maybe forecaster frames, how that can also be interoperable with Celo. And finally, some social connect use cases. And I'll dive into what social connect is. So earlier when I was talking about MiniPay, you can map phone numbers to wallet addresses. That is powered by a protocol on Celo called Social Connect. And this maps off-chain personal identifiers like a phone number, email, maybe a Twitter username to an actual wallet address. So think of like ENS, but actual identifiers we already have. What's cool is because every single person who uses MiniPay or Valora is actually creating a Social Connect identifier. This means that Social Connect is actually one of the largest on-chain identity protocols within the crypto ecosystem. And we already have over 3.5 million registered identifiers. It also really improves payment UX. So instead of having to send transactions to a wallet address, you can just send it to someone in your contact list. And what this means now is you will have a social graph of one of the best social graphs because you have your entire contact list as a social graph. And this really improves functionality for apps and what this can enable for maybe social apps as well. Some useful tips to keep in mind as you're trying to build on Alphahora's L2 is that this L2 is new, and we really need your feedback to improve it. This is an ongoing process. Celo is an ecosystem of contributors and builders, and the way that Celo improves is with builder feedback. So if you're trying to build on our Alphahora's L2 that just launched last month, and there's anything missing, make sure to check out our docs, and you can find our GitHub discussion page. Add in your feedback, add in your support, get involved in the ecosystem. Maybe we'll make that into bounties and offer bounties for people who are supporting and improving our testnet. The second thing is Social Connect is still in early development from a builder standpoint. So if you're new to building on Social Connect, we really, really need your feedback for improvements for improving the developer experience. And you can be one of the first builders to explore building on Social Connect. So this is another really great opportunity, and you can really lead the way for there. So just to recap, Celo is on a mission to is a mission-first, planet-positive blockchain ecosystem leading a thriving digital economy. We are trying to create a blockchain that's built with purpose and built for all. And if you want to get started building on Celo, check out this QR code. It has all of our cheat sheets. I also have some physical hard cheat sheets with me that I can hand to all of you guys at the end. And come by the Celo booth. It's on the opposite side of the venue where we will have those cheat sheets. You can check them out. They'll have links to our faucet, our explorers, tips for quick starts, everything you saw on the slides, more information about our bounties, app ideas, and everything, where to get support. Everything is on these cheat sheets. So go check them out. And that's all. Do we have time for a quick question? For a question, if anyone has anything.
I have a question about connecting to the phone number. And the, you know, like I have a phone number that I've had for 20 years. And then now it's become a bit of an identity. So I'm thinking, but it's not global, it's connected to the US. So I'm thinking, are you seeing like connecting, like a Google Voice or something that's a digital one that would be valid in every country, then to connect to the new application you're putting together?
Yeah, if I'm understanding your question correctly, it's if you have a phone number, are we seeing people using like a separate phone number to use these, or they're using their existing phone number?
Their existing phone number.
Okay, So most people will be using like their main phone number, like the one you've had for 20 years, but it's not actually stored on the blockchain. So Social Connect uses a protocol called Otis, which actually is like identity. It hides the actual phone number and wallet address. It just maps it. So it's not actually, you can't see your phone number from just the blockchain. You'll have to call a lookup and registry function to pull in the information. So most people are using their actual like phone numbers, but it's not, you're not posting your phone number like for everyone to see. It's, you need this function to like unwrap it and actually process it.
I see. So not like WhatsApp.
Yeah, exactly. Cool. Well, if you have any more questions, come find me at my booth, at the Cello booth, and you can talk to anyone who's wearing a crypto. Yeah, not everyone who's wearing a crypto uses this shirt, because there's lots of us, but come find anyone on the Cello team. Thank you.
Do you want to mirror it or just present it and have another thing on your screen? Mirror is okay. Okay, just make sure on the display settings you select mirror. Display, please. Exactly. Now, they will change it when you start your talk.
Hello, hello, hello. Testing. Volume is fine? Volume is fine? It's kind of low. Okay. Hello. It's like this or like this? Like this? Like this? Like this? Here is okay? Okay. Hey everyone, I'm Fabri from the XMTP team. The parent company is called Ephemera, and we are the developers of the XMTP protocol called XMTP, of course, the app that is called Converse, and now presenting MessageKit. So we are owning all the layers of the stack. Everything is open source. Everything is going to be soon decentralized. So you can think of building on top of the protocol an inbox, or you can think of building on top of the app agents, bots, mini apps, everything that is fun for developers today. So we are going to go deep into how to build agents using MessageKit. And so for that, we are introducing MessageKit, which is a framework for building bots and AI agents on top of the XMTP protocol. Everything on top of the XMTP protocol is encrypted end-to-end, open source, and soon to be decentralized. So we are going to dive deep into what kind of things we can build. And for that, we defined what we call AI skills. And AI skills is a 5-step approach to reasoning. So to build cool agents that are smart and can perform actions. So we are going to go step by step, like an overview. And this is all, of course, documented in the docs. But this is what I'm trying to... So we are going to start with a demo. This is what the reasoning agent looks like. And this agent is going to be interacting with ENS. It's going to be interacting with domains, registering, renewing, doing fun stuff with ENS domains. So let's put play. This should take like a minute. This is the Converse app. I'm starting a conversation with an agent. This is called ENS agent. Recognize that I'm Fabri. That's my Converse username. It's fetching that from an API. also recognize is registered. Fabric.eth is registered. So now it's offering me cool alternatives that I can use to register a ENS domain. So Fabric LFG actually is available, so points me to the website, easy enough. Now, what else can we do? So yeah, so I was curious, who's the owner of Fabric? Because my name is Fabric, so I wanted to know more about this owner. Apparently, we can get the domain information. It's also fetching from the ENS APIs. And he's asking me if I want to tip him for getting there first. Sure, let's tip him. And this is just to show that I'm able to tip from an agent. I'm able to perform a transaction. This is going to send a frame. So this frame triggers a base transaction. By default is 1 USDC. That's what we think of when we say tipping, maybe $1. And as you can see, the agent understands everything that I say. I don't need to perform like very strict commands. Can I renew it? No, you can't. It's not yours. So in the backend, this is how reasoning looks like. It knows that I'm not the owner of Fabric, and then performs action based on that. Can I register Vitalik? No, you can't. It's registered. So understands the context, understands my name, my domain, and you can just have a conversation with the agent, and the agent is going to be as smart as you can wish. What else is in this demo? Okay, so that's reasoning. That's the end of the demo. So now we are going to go backwards. How can we achieve this type of interaction with an agent using MessageKit? So as I was saying, there is a 5-step approach. So we are going to start with reasoning. Now we are going back to fine-tuning, which fine-tuning may be the most important thing. So if you see this piece of code, this is how I train this agent. This is all that is needed in the prompt, besides, of course, the code that goes and checks the APIs. But this is why the bot is smart. This is called fine-tuning. It's not that hard. When you hear that you need to train a bot or you need to fine-tune a bot, this is actually what training and fine-tuning looks like today. So it's basically giving example interactions and how to respond based on those interactions. And you will see that I'm using new lines as separators, and maybe after a new line, you see a command. So that command is going to be performed internally by the bot. So that's, well, fine-tuning is a very important step to make the bot smart. Before fine-tuning, we are going to embed that fine-tuning into the whole system prompt. So a system prompt is the thing that you're going to send to the agent, and then you're going to also send the ongoing messages, so it has memory. So in this example, for creating a system prompt, we are using some prompt rules, which is, you can see them on our docs. It's like, don't be rude, be helpful, you are a funny agent on a Web3 messaging app, don't guess, don't make assumptions, like guidelines and things to the bot to behave. Then we are giving context of the user who is speaking to the agent. That's fetching information about your ENS or Converse username. Also recognize if you have an ENS domain and has all your information, your wallet address. So the bot is aware in every interaction of your context as a user. Then it's going to parse all the skills. We call them skills, which are the actual skills, like checking an ENS domain with an API. And fine-tuning, and then we end that fine-tuning. Maybe we want to replace some values, like you can see values between the slashes, like ENS domain or preferred name. So we can do like a refresh based on the, customized to each user. So after we generate the system prompt, I can show an example later, but it's not that long. We get into processing. So processing is, hey, I want to check if Vitalik ETH is available. Now it goes into parsing. The agent is going to, based on our fine-tuning, this interaction may be somewhere here. So the agent is going to split the response into 2 lines. And the second line is check italic, because it starts with a slash, the agent recognizes that it's a skill that needs to be executed. So below you are going to see that how it iterates through the messages of the array. And if it starts with a slash, executes the skill. If not, assumes it's a simple message, and just sends you a response. Now going deeper, this is how parsing looks like. So we have, now we need to execute the skill, the check vitalik.eth. So what happens here is that internally, this command is sent to MessageKit, and MessageKit returns a JSON. This JSON says the skill is called check because it's already defined. We are going to see how to define skills. And these are the parameters of this particular skill. And you can see the domain, and it's available in a JSON format. So now you get to the code, and you're able to play around with the parameters and the command. If it's, instead of check there was a typo, this wouldn't work. So this command needs to be very strict, and the AI agent knows that these commands are strict, so they always get reliable responses. So what happens after we have the values? Now we handle them. So in this example, this is how to handle the check skill. I'm receiving the domain as a parameter, which was vitalik.eth. Then I'm using one of our functions that is getUserInfo. It's going to give me information about vitalik.eth, like address, domain, description, profile picture, and so on. And it's checking, okay, if there is an address, hey, looks like, sorry, if there is not an address, means that the domain is free. So that's the response that you see in the demo. And if it found an address, then it's registered, so it's already registered. Let's propose some cool domains. And now I'm executing the cool skill internally, which is going to return 5 examples. 5 cool examples like Fabry LFG, like we saw. Finally, this is how we create the check skill. So it's basically like a JSON structure, very similar to how you define in Discord or Telegram bots. So you will say, this bot, which has a tag ENS, at ENS, you can use that tag inside a group chat, for example, and it's going to recognize that you are tagging that bot. And it has more skills in the demo. This, I'm just showing the check skill. So the check skill receives 1 parameter. You can see that, domain between brackets, triggers, just like a double check to see if the skill is triggered, examples of how this command should be used. These are all parsed into the system prompt automatically. So this is what gives the smartness to the bot. It's very important. This part is also very important to be defined very clearly. And then we define the type of parameters that we get. So in this type is a domain, is a string, but we could check if it's .eth or if it's a URL or maybe a EVM address. So now that we have seen how to get to reasoning, again, all of this was demoed on Converse. This is our open source app. It's available on the App Store. And it's going to allow you to interact with bots created on MessageKit. Each bot created on MessageKit is just as any other user in Converse. You will need a private key, and it creates an account, and then you can talk to that account. So we are going to see one last demo with different skills. All these examples are open source, are available in the docs. And this is called base agent. And I want to show how base agent looks like. So, okay, let's see the demo first. You can see like converse.xyz.baseagent because every profile has its own like landing page on Converse. So people can chat to you like a deep link into messaging you. And we are going to also see something more interesting that is real transactions. So this bot can help me with swapping, with minting, with requesting testnet funds. So let's say I want to swap. Okay, this is going super fast. Let's say I want to swap. So it has a frame. This frame receives the swap parameters that were parsed by the agent and creates a ready-to-go button that is going to trigger swap in one, maybe in Coinbase Wallet. So 1 ETH for USDC. Again, this is using all the skills that we saw defined and fine-tuned and then parsed. Now let's say we want to mint. In this example, I'm going to use, we have many ways of minting. I just want to send the Sora URL, and it will return me an open frame that is available to mint on any minting frame. So that's one way of minting also, triggering a frame. Now let's see, let's try to pay, in this example, this is my manager called Sol, and I'm going to try to pay 1 USDC to Sol. Sol is his username in Converse. And this is how it looks. Tip Sol, triggers Coinbase Wallet, you just send 1. Again, these frames are customizable. You can send any receiver address, any amount, any token, any chain, and they will just be triggered in the wallet. Finally, if you need testnet funds, you can go to Base Agent. It's asking me Sepolia or go early. Sepolia is fine. Now it's connecting to the APIs of Learn Web3. They provide faucet testnet in a very convenient way. And as you can see, it gives me a receipt with the transaction that we just saw. So that was Base Agent. Now, how much time do we have left? We have? Okay, any questions so far? Yes.
I wanted to understand if this is a conversational app. So in case I tell that I want to swap 1 USDC, and then in the it responds back, and then my following question is, okay, let's make that 5. So does it understand the context of the previous chats?
Yes. So there is one thing that it's called memory.
Yeah.
And right now I'm using only what I call short-term memory.
Oh, okay,
Every
got it.
time you restart the bot, it
The
starts
memory
fresh.
says, yeah, got it.
But if you keep speaking, it's like the memory is there.
It's in memory.
Yeah.
Right? Yeah. Okay. My second question is this kind of scalable? Because from what I understood is that it splits your question into bunch of, instructions and commands.
Yeah.
The passing, and then based on the commands, it's executing, and then after that execution, it's kind of a handler if-else statement kind of thing. So
Yeah.
if it's /check vitalik.eth, then execute this skill, blah
Yes.
blah blah. But then is it kind of scalable? Because if you build 5 skills, okay, if you, just add 5 skills, then it would only work for 5 skills, but it would not know how to combine those 5 skills and work, right?
To combine?
To combine in the sense, if I ask, let's say, can you check if vitalik.eth is available and also send 1 USDC to Sol?
Yeah.
Is that possible?
Yes. I only show an example that used, like this one was only, I want to check if Vitalik is available, right? And it answered in 2 lines. Your question will return more lines.
Yeah, so how would it understand which, okay, so you're just picking up the command from there and executing it one by one?
Yes.
Okay, got it.
Yeah, and you can even let's check out the docs real quick. Maybe you are in the middle of multiple command processing, like you need to ask 5 questions. So you will use something like this. By the way, this is message kit, these are the docs. You can start with a very simple CLI, and you will have 3 examples. The ENS agent, a group bot with use cases like tipping, payments, and so on. Middlewares, like how to connect with external APIs. For example, I'm using this for the testnet funds. And to your question, maybe you need more, maybe you need the bot to answer a specific one between commands, so you can await for a response.
Okay, got it.
This will allow you to execute multiple commands, but in between, let the user interact with them.
Got it. Thank you so much.
Yeah. And this is very new. So I hope it works, but let me know. Yeah. Yeah, no, it's okay. Um, okay, I can. Any other questions? I can demo the CLI. So we have more time. If anybody has questions, don't hesitate.
Okay, I had an. Should I go? I had
Yeah,
another
yeah.
question. So how difficult is it to integrate an external API in case I want to build something that is a bit new? Let's say not a base agent, not a crypto related stuff.
Yeah.
But something else. So if I want to integrate some external APIs, a bunch of external APIs, add a bunch of skills, how difficult is that to do it?
Yeah, so they are, we call them middlewares.
Okay.
So for example, you will just, in this case, I use the Chrome middleware to send daily updates if you subscribe to a bot. So you just have this file, for example, and then you would integrate that into your handler, your main handler. So this is the full ENS bot
Okay.
with all the skills. So as you can see, I have a reset skill, I have a register, how to register ENS domain, and each one of these code blocks can talk to any external API
Got it,
and
got it.
return a response. And you can put those files inside, like, I like this structure. So this is the structure of a bot. So what I would do is to, so index, skills, and prompt are like the basic stuff. And then I will put into handlers or maybe a lib folder all the external APIs and middlewares.
Yeah, got it.
Yeah, so these examples don't use that many because are the basic ones, but if you, yeah, like for example, if I go to Friends Day, so we were hosting Friends Day a couple of days ago, and we were managing 5 different bots. Each bot would perform a different action. So you had Earl the bot. Earl would onboard you to the event and add you to the group chat. Then you had B2, who was delivering popes. Then you had Cusco, which was the ENS agent that we just saw, just copy-pasting the code and calling it Cusco. And then Peanut will give you advice about DevCon side events, and Peanut will give you advice. No, we allow you to play Wordle in a frame. So in this example, maybe it's more, you can see how the file structure it is. But I have, so I'm fetching the event API from the ENS team. I'm also using a local database, LowDB. I'm using cron because the bot send the updates like, hey, Vitalik is about to speak. So this is more like a complex bot. I also have local data, like this was the structure of the popes and the subscribers. You could also see more handlers. And in this case, you will start the 5 bots. You will start like 5 runners, each runner of for 5 bots inside one bot. And each handler will have its own like bot name, and so you will be see clearly who is talking to whom. Yeah, this is just like a cool example.
Thank you so much.
Sorry, is there any like nice vector database that is decentralized or Web3 vector database that you might advise us to use?
The database in Web3.
Yeah, vector database.
Vector database?
Yeah.
No, I haven't tried any. No, that's interesting. Why are you thinking about a vector database?
I don't know. Maybe RAG or something.
Yeah.
Like talking.
No, I'm using JSON databases, simple stuff, because for more complex stuff, I recommend you using Brian SDK. or Agent Kit from Coinbase. So the cool thing is that Message Kit plays well with all of them. So Message Kit, you can think of Message Kit as more on the UX side of agents. And then if you're going to perform like more deep skills on chain, like agents autonomously performing swaps, then you would need more like hardcore infrastructure like Brian SDK or Agent Kit from Coinbase. But you can combine both, like making it fun and easy to use, but also complex and even integrating LangChain, for example, and using vector databases with LangChain. This is a node backend, so there is no limits to what you can build, honestly. Yeah, just trying to keep it simple in the examples, but hopefully you manage to build cool stuff. Okay, and that's how you start with Message Kit. That's the CLI. I put any name. You're going to see that on the right I have Converse, on the left I have the repo. This is the ENS agent demo. Because I don't have my private key set, it's going to generate a random one for me, which I can just copy paste. So each time that I start the bot, it's going to keep the same address. Again, we have the skills, we have the prompt, the index, and now it's even deep linking me to Converse, so I can say hi. I don't have the OpenAI API key. Yeah, no OpenAI key found. So if you input now your OpenAI key, this is going to be like just the example that I showed before. And if you want to see how a system prompt looks like in full, you go, again, these are the 5 AI skills: reasoning, fine-tuning, prompting, processing, parsing, and definition. And in prompting, you will find the full prompt. This is the full prompt. So initial rules, it was very hard to get to these ones, like every word counts. So yeah, if you change any detail, this could like work very bad. User context, this goes and fetches information from ENS or Converse APIs. Then parses the skills automatically. So now the bot knows what are the skills and how to use them with examples, very important. And then we will go into the fine-tuning, example responses. And that's it. That's a full system prompt for the bot. Shouldn't be more complex than that for 6 skills. The more skills, of course, the more complex. Yeah, then you are going to find more information about XMTP, like how you receive a text message, how you receive a reply, how you receive an attachment like an image, how to use GPT Vision for interpreting an image and splitting the bill. There is an example. So lots of examples, everything open source. You can go here. Happy to help you building along the weekend. And if you have any questions, we are going to be at the booth. So yeah, thank you. Let me introduce myself. Where is the, because I was called Fabri, but I'm not Fabri anymore. I'm humanagent.eth now. This is my new identity, and I'm very happy about my new domain. So yeah, product and developer at Ephemera. Happy to talk to you after this talk. Thank you so much.
Really nice one. I enjoyed this.
You like it? Yeah, it's fun.
Yeah, it's really. Are you the Yeah. Yeah. I couldn't register as a hacker because I was too late, but really interesting stuff. I'll check it out.
You live here?
Sorry?
You live in
No, I came from this. But I won a hackathon in Romania like 2 weeks ago, and the organizer asked me if I'm going to this one. I said no, and they said yes, you are.
Okay.
Yeah, and they sent me here.
Good for you.
Yeah, it's awesome.
Nice. Okay, stay around.
Yeah, exactly. See you around.